There is a fact about quantum mechanics that has been sitting in the published literature since 1970. It is not classified. It is not controversial. It has been experimentally confirmed by multiple independent research groups across 5 continents. And it directly contradicts the version of the story that every popular science video, every documentary, every late-night Wikipedia spiral has been feeding you for decades. The observer does not collapse the wave function. Consciousness has nothing to do with it. The idea that your mind plays a special role in determining the outcome of a quantum measurement was never the mainstream position in physics. It was a minority interpretation proposed in the 1960s, abandoned by its own creator by the 1980s, and experimentally falsified with a p-value of 10 to the negative 16th in 2018. And nobody told you, before we dive in, if you want to support the channel and get exclusive content on all things space and physics, check out our Patreon. Link is in the description. The reason nobody told you is not a conspiracy. It is something worse. The real version of this story involves a physicist who solved a problem in 1970 and was punished for it. A replacement framework that works with terrifying precision, but runs on a concept that nobody can physically define, and an implication about the nature of reality that the scientific establishment has quietly avoided discussing in public for over 50 years. In 1982, a physicist named Wojciech Zurek published a paper in Physical Review D, volume 26, page 1862. That gave a name to the process that actually determines what you see when you look at a quantum system. He called it Einselection, environment-induced superselection. The paper demonstrated mathematically that the environment itself, every stray photon, every air molecule, every particle of thermal radiation, performs the role that popular science had assigned to your mind. The environment observes, the environment selects, the environment decides what gets to be real. Not you. A rock observes as effectively as a physicist. That is not a metaphor. That is what the equations say. And the man who first realized this, who published the original paper 12 years before Zurek, a German physicist named Heinz-Dieter Zeh, was punished for it. His career was damaged. His students could not get jobs. The physics establishment treated him not as someone who had solved one of the deepest problems in quantum mechanics, but as someone who had committed an act of professional indecency by even asking the question. He died in 2018. He never received a Nobel Prize. 2 other physicists received the 2012 Nobel Prize in Physics for experimentally confirming the phenomenon he predicted. Their names are Serge Haroche and David Wigner. His name appears in none of the headlines. And here is the part that should disturb you. The thing that replaced consciousness, the thing that physics now says actually determines what is real and what is not, is something far stranger, something that every physicist uses and none of them can define. They call it information. And if you ask a physicist what information physically is, what it is made of, where it lives, what kind of thing it is in the ontology of the universe, you will get silence, or you will get a definition that is circular, or you will get a different answer from every person you ask. We removed consciousness from quantum mechanics. The replacement is worse, and nobody is talking about it. To understand what the problem actually was, not the version you were given, the real version. And the real version starts in 1932 with a man who was arguably the smartest human being of the 20th century, and a book that accidentally broke physics for almost 100 years. John von Neumann was born in Budapest in 1903. By the age of 6, he could divide 8-digit numbers in his head. By 22, he had published foundational papers in set theory, quantum mechanics, and operator algebras. He essentially invented game theory, contributed to the development of the atomic bomb, designed the architecture that every modern computer still uses, and in his spare time formalized the mathematical foundations of quantum mechanics in a book called Mathematische Grundlagen der Quantenmechanik, published in 1932. The English translation came out in 1955 from Princeton University Press. In that book, von Neumann identified something that nobody had properly confronted. He showed that quantum mechanics contains two completely different rules for how reality evolves. He called them Process 1 and Process 2. And the numbering is counterintuitive, so pay attention. Process 2 is the normal one. It is the smooth, deterministic evolution described by the Schrödinger equation. A quantum system glides through superposition, all possibilities coexisting, no contradiction, no drama. Process 2 is elegant. Process 2 is the part of quantum mechanics that everybody loves. Process 1 is the violence. Process 1 is what happens when you measure. The wave function collapses, the superposition disappears. One outcome is selected. The selection is random, governed by probability, and it is irreversible. One moment the system is in a superposition of spin up and spin down. The next moment, it is spin up, period. No mechanism, no explanation, just a rule that says, when you measure, this happens. Von Neumann then asked the obvious question that nobody wanted to hear. If quantum mechanics is universal, if it applies to everything, then the measuring apparatus is also a quantum system, and the apparatus that measures the apparatus is also a quantum system. And your retina, which detects the signal from the apparatus, is also a quantum system, and your optic nerve, and your visual cortex, and your brain. Where does process 2 stop and process 1 begin? Where in this chain of quantum systems does the smooth evolution suddenly shatter into a definite outcome? Von Neumann showed, with mathematical precision, that you can place the boundary anywhere. You can say, collapse happens at the apparatus. You can say it happens at the retina. You can say it happens somewhere in the brain. The predictions of quantum mechanics remain the same, regardless of where you draw the line. He wrote on pages 419 to 420 of the 1955 translation that this boundary can be pushed arbitrarily deeply into the interior of the body of the actual observer. And he invoked what he called the principle of psychophysical parallelism. Now, recent scholarship, particularly a 2025 paper in Studies in History and Philosophy of Science by Joram Muderman and Dennis Deeks, has argued that von Neumann himself did not actually conclude that consciousness causes collapse. His treatment of the observer was a mathematical tool for defining boundaries, not an ontological claim about the nature of mind. But the door was open, and in 1939, two physicists walked through it. Fritz London and Edmund Bauer published a slim 51-page monograph called La théorie de l'observation en mécanique quantique, the theory of observation in quantum mechanics. They took von Neumann's chain argument and pushed it further. They argued that the observer, through what they called introspection, separates themselves from the observed system, thereby creating a definite outcome. The conscious self breaks the chain. The I that looks is the thing that makes reality decide. What is almost never mentioned is that London had studied Husserlian phenomenology before turning to physics. Stephen French's 2023 book from Oxford University Press revealed that London's consciousness was a specific philosophical concept, relational and phenomenological, not the crude causal mechanism it was later taken to be. They were not saying your mind magically zaps electrons. They were making a careful argument about the structure of observation within a particular philosophical tradition. But careful arguments do not survive popularization. The nuance was stripped away. The headline remained, "Consciousness collapses the wave function." And then came the man who made it impossible to ignore. Eugene Wigner was born in Budapest in 1902. 1 year before, von Neumann and the two were classmates at the Lutheran Gymnasium. Wigner went on to win the 1963 Nobel Prize in Physics for contributions to nuclear and particle physics. But his most famous contribution to quantum foundations came in 1961 in an essay called Remarks on the Mind-Body Question. And here is a detail that is almost never mentioned. The essay was published in a book called The Scientist Speculates, an anthology of partly baked ideas, edited by I.J. Good, published by Heinemann in London. Partly Baked Ideas. That is the subtitle of the book that launched the consciousness interpretation into the mainstream. I want you to hold that detail because it is going to become relevant later. Wigner wrote a sentence that would echo through decades of physics and philosophy. He wrote, "It was not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to the consciousness." And then he devised a thought experiment that made the problem viscerally clear. Imagine a friend of Wigner's goes into a sealed laboratory and measures a quantum system. The friend sees a definite result. Spin up, say. Inside the lab, from the friend's perspective, the wave function has collapsed. But Wigner, standing outside the lab, must describe the entire laboratory, friend included, as a quantum system. And quantum mechanics says that until Wigner himself looks, the friend, the apparatus, and the particle are all in superposition together. The friend is in a superposition of having seen spin up and having seen spin down. If consciousness causes collapse, then the friend's consciousness already selected an outcome inside the lab. But if the friend's consciousness counts, why does Wigner need to look at all? And if Wigner's consciousness is the one that matters, then the friend was in superposition, not conscious of a definite result, until Wigner opened the door, which would mean the friend's report of having seen a definite result earlier is somehow retroactively created by Wigner's observation. This is Wigner's Friend, and it is genuinely disturbing. Not because it proves consciousness matters, but because it shows that if consciousness matters, the consequences are absurd. Every conscious being becomes the center of their own collapsing universe. Your version of reality only becomes definite when you look. Everyone else exists in superposition until you observe them. That is solipsism, wearing a lab coat. But here is what you were never told. Wigner himself abandoned this interpretation. By the early 1980s, he had publicly recanted in a 1983 paper called Review of the Quantum Mechanical Measurement Problem, published in Quantum Optics, Experimental Gravity, and Measurement Theory by Plenum Press. Wigner wrote that his earlier view should be criticized as solipsism. He moved towards spontaneous collapse theories, the kind that would later be formalized by Girardi, Rimini, and Weber in 1986. The man who launched the consciousness interpretation abandoned it. And the argument that convinced him came from the most unexpected place. It came from a German nuclear physicist who nobody in the Foundation's community had heard of, working alone in Heidelberg, who had been trying to tell the world for over a decade that the entire problem was already solved. His name was Heinz Dieter Zurek, and his story is one of the great injustices of 20th century physics. Zurek was born on May 8, 1932, in Braunschweig, Germany. He studied physics at the Technical University of Braunschweig and then at the University of Heidelberg, where he earned his doctorate in 1962 under Hans-Georg Mang in nuclear physics. His academic lineage ran through Nobel laureate J. Hans D. Jensen. From 1964 to 1968, he held research positions at Caltech and UC San Diego. He returned to Heidelberg, rising from lecturer to professor of theoretical physics, a position he held until retirement. None of that biography tells you anything important. What tells you something important is what happened to his mind in the late 1960s. Zurek was working on deformed heavy nuclei. This is dense nuclear physics, about as far from philosophy as you can get. He was studying approximation methods for stationary states, and he became, in his own words, irritated. The irritation came from a specific technical observation. Nucleons inside a deformed nucleus effectively observe an apparent orientation even when the overall system has perfect rotational symmetry. The parts of the system see a definite shape. The whole system has no definite shape. The parts are behaving as though they have measured something that the whole system says does not exist. This led Zurek to what he later called his weird speculation. He drew an analogy. If nucleons inside a nucleus can effectively observe an orientation, then any subsystem entangled with a larger system could be doing the same thing. And if the larger system includes the entire environment, photons bouncing off surfaces, air molecules colliding, thermal radiation flooding every cubic centimeter of space, then the environment is already doing the observing, all of it, all the time, trillions upon trillions of times per second. You do not need a conscious mind, you do not need a laboratory, you do not need a physicist. The universe is already measuring itself. Every interaction between any two quantum systems is an act of observation. Zurek wrote about this period. It was absolutely impossible at that time to discuss these ideas with colleagues, or even to present them in a publication. He tried anyway. His paper on the interpretation of measurement in quantum theory was rejected by mainstream physics journals. It eventually appeared in Foundations of Physics, Volume 1, Issue 1, pages 69 through 76, in 1970, the very first issue of a brand new journal. That is where the most important paper in quantum foundations since von Neumann's book had to be published. Not in Physical Review, not in Nature, not in any journal that the physics establishment would have seen on their desks, in a journal that did not exist until the month the paper came out. The argument was devastatingly simple. Quantum systems cannot truly be isolated if they are macroscopic or even mesoscopic. The environment constantly interacts with them, and these interactions are quantum mechanical interactions, which means they create entanglement. The environment becomes entangled with the system. The scattered photons now carry information about which state the system was in. And once that information is distributed across billions of environmental particles, the quantum superposition, from the perspective of anyone who does not have access to every single environmental particle, is gone, not because it collapsed, not because consciousness intervened, but because the coherence, the delicate phase relationship between the superposed states, has been diluted into the environment beyond any practical possibility of recovery. The classical world emerges naturally from quantum mechanics when environmental interactions are properly accounted for. No consciousness required, no collapse postulate needed, no special role for minds, eyes, brains, or PhDs. Serge did not even use the word decoherence. That term would not appear until around 1989. He did not use the word entanglement either, referring instead to quantum correlations, because Schrödinger's original term Verschränkung was so rarely used at the time that it barely registered. I want to stop here for a moment and make sure the weight of this lands properly. In 1970, a working physicist published a paper that resolved the central mystery of quantum mechanics, the mystery that had haunted the field since 1932, the mystery that had driven Wigner to invoke consciousness, that had generated decades of philosophical confusion, that had made the measurement problem seem like it required something outside of physics to solve. Serge showed that it did not. The answer was already inside the equations. It had been there the whole time. The environment does it. You just have to include the environment in your description of the system. And the physics community ignored him. Not passively, actively. His own PhD supervisor Jensen told him, in German, "Schlafende Hunde soll man nicht wecken." Let sleeping dogs lie. This was not a suggestion. It was a warning. Foundational questions about quantum mechanics were not acceptable research topics. They were career poison. The Copenhagen interpretation had declared the measurement problem solved by fiat, by simply refusing to ask what happens during measurement. And anyone who reopened the question was treated as professionally irresponsible. The primary antagonist was Leon Rosenfeld, Niels Bohr's closest philosophical ally and the self-appointed guardian of Copenhagen orthodoxy. According to Adam Becker's 2018 book What is Real, published by Basic Books, Rosenfeld lobbied against Serge so effectively that Serge's students could not find academic positions. Serge himself said this was something he would never be ready to forgive. A Physics Today review later noted that as late as the 1980s, Dieter Serge's work on decoherence theory had serious consequences for him and disastrous ones for his students. Historian Christian Camilleri documented the structural inequality with precision. He wrote that unlike Zurek, Serge did not enjoy the luxury of the backing and support of senior colleagues, whereas Zurek benefited immensely from his association with John Wheeler, whose reputation gave him the freedom to pursue foundational questions. Serge found himself increasingly marginalized in Heidelberg, with little prospect of professional advancement. That sentence deserves to sit for a moment. Two physicists, the same idea. One had Wheeler's backing, one did not. The one with backing got the career, the citations, the influence. The one without got isolation and a warning to stop asking dangerous questions. And the deepest irony of all is this: the only prominent physicist who responded positively to Serge's 1970 paper was Eugene Wigner, the man whose consciousness interpretation Serge's work would eventually destroy. Serge wrote, "After I had completed the manuscript for my first paper on what is now called decoherence, the only well-known physicist who responded to it in a positive way for a long time was Eugene Wigner. He helped me to get it published." Wigner also arranged Serge's invitation to the landmark 1970 Vienna Conference on Quantum Foundations, organized by Bernard d'Espagna. Think about that. The man who said consciousness is necessary for quantum mechanics was the only person who championed the man who proved consciousness is not necessary for quantum mechanics. And then, over the following decade, Wigner read Serge's work carefully, thought about it seriously, and changed his mind. In that 1983 paper, the one where Wigner abandoned his own interpretation, he wrote, "The argument which convinced me that quantum mechanics validity has narrower limitations, that it is not applicable to the description of the detailed behavior of macroscopic bodies, is due to Dze. Due to Dze, 4 words. The creator of the problem credits the destroyer of his solution. And nobody told you." Zay himself coined a phrase for the decade that followed his 1970 paper. He called it the Dark Ages of Decoherence. He wrote about it in his 2006 essay, Roots and Fruits of Decoherence, published by Berkhauser. For over 10 years, the idea sat in the literature, ignored, while the consciousness interpretation continued to spread through popular culture, through New Age bookstores, through documentaries that told you your mind shapes reality. The rescue came not from Heidelberg, but from Texas, and it came wearing Wheeler's stamp of approval. Wojciech Zurek was born in Poland in 1951. He earned his master's degree from AGH University in Krakow in 1974, and his PhD from the University of Texas at Austin in 1979. His advisor was John Archibald Wheeler. That name matters more than almost any other detail in this story, because Wheeler was one of the most connected, most respected, most institutionally powerful physicists in the world. He had worked with Bohr. He had coined the term black hole. He had mentored Richard Feynman. When Wheeler took an interest in something, the physics community paid attention. When Wheeler's student published a paper, the physics community read it. Zurek and Wheeler co-edited Quantum Theory and Measurement, published by Princeton University Press in 1983. It was the definitive anthology of foundational papers, and it reprinted Serge's 1970 paper. But it was Zurek's career, not Serge's, that the book advanced. Zurek's 2 foundational papers did what Zay's paper had not been allowed to do. They made decoherence respectable. The first, Pointer Basis of Quantum Apparatus, Into What Mixture Does the Wave Packet Collapse, appeared in Physical Review D, Volume 24, page 1516, in 1981. It introduced the concept of pointer states, the preferred quantum states that survive environmental monitoring. Just as a measuring instrument's pointer settles on definite readings, the environment selects specific states as stable while destroying all superpositions of those states. The second, the one that gives us the word Einselection, appeared in Physical Review D, Volume 26, page 1862. In 1982, environment-induced superselection, and the mechanism, when you see it clearly, is almost offensively simple. A quantum system exists in superposition. It interacts with its environment. The environment becomes entangled with the system. Scattered photons, for instance, now carry which state information. When you trace over the environmental degrees of freedom, which means when you account for the fact that you cannot possibly track every photon and air molecule, the system's density matrix diagonalizes in the pointer basis. The off-diagonal terms, the interference terms, the terms that represent the quantumness of the superposition, vanish. The system now appears to be in one definite state with classical probabilities. No consciousness required, no collapse postulate. The environment does it automatically. universally, ceaselessly. Zurek wrote in his landmark 1991 Physics Today review article that any information transfer, not just deliberate measurements carried out by observers and measuring devices, but also accidental monitoring by the environment, will have measurement-like consequences. A photon bouncing off a dust grain constitutes observation just as much as a physicist looking through a microscope. The environment is a universal, unconscious, ceaselessly operating, measuring apparatus. And the speed at which this happens is one of the most stunning numbers in all of physics. Eric Juice and Serge calculated the decoherence timescales in their 1985 paper in Zeitschrift für Physik B, volume 59, pages 223 through 243. For a dust grain floating in air, roughly 10 micrometers across, the decoherence time is approximately 10 to the negative 31 seconds. That is a millionth of the time it takes light to cross a single proton. For a 1-gram object at room temperature in a superposition separated by 1 centimeter, the ratio of decoherence time to relaxation time is approximately 10 to the negative 40. Even if the relaxation time equaled the age of the universe, about 10 to the 17 seconds, quantum coherence would be destroyed in 10 to the negative 23 seconds. I need to make those numbers visceral because they are doing enormous work. 10 to the negative 31 seconds for a dust grain. Light travels at 300 million meters per second. In 10 to the negative 31 seconds, light moves about 3 times 10 to the negative 23 meters. The diameter of a proton is about 10 to the negative 15 meters. So in the time it takes the environment to destroy the quantum superposition of a single dust grain, light has traveled a distance roughly 100 million times smaller than a proton. The environment is not slow about this. The environment is ferocious. The environment does not negotiate with quantum mechanics. It annihilates superpositions with a violence that makes the word collapse sound gentle. Max Tegmark calculated brain-specific timescales in a 2000 paper in Physical Review E, volume 61, page 4194. Neuron-firing superpositions decohere in approximately 10 to the negative 20th seconds. The dynamical timescale for a neuron, the time it takes to actually do anything, is 10 to the negative 3rd to 10 to the negative 1st seconds. That is a gap of at least 17 orders of magnitude. Even microtubule excitations, the substrate of the Penrose-Hameroff consciousness theories, decohere in approximately 10 to the negative 13th seconds, femtoseconds. Tegmark concluded that the brain is, by his calculation, squarely in the classical category, by a margin exceeding 10 orders of magnitude. Your brain is not a quantum device. Your consciousness does not interact with quantum systems in any way that physics can detect. The numbers are not close. The numbers are not ambiguous. The gap between decoherence timescales and neural timescales is so vast that invoking consciousness in quantum mechanics is like invoking your personal gravitational field to explain why the sun rises. Technically, your mass does exert a gravitational pull on the sun. The magnitude of that pull is so laughably small compared to the actual forces involved that including it in your calculations would be an act of vanity, not physics. But that is not even the disturbing part. The disturbing part is what happened when experimentalists went into their laboratories and tested these predictions directly, because every single experiment confirmed decoherence. Every one. And what the experiments revealed is far stranger than consciousness ever was. Serge Haroche was born in Casablanca, Morocco, in 1944. He moved to France as a child and studied at the École Normale Supérieure in Paris, eventually becoming a professor at the Collège de France. His specialty was cavity quantum electrodynamics, the study of how atoms interact with photons trapped in small reflective cavities. And in 1996, Haroche and his team achieved something that the entire Decoherence program had been waiting for. They watched a Schrödinger cat state die. The experiment, published as Brun et al. In Physical Review Letters, Volume 77, page 4887, on December 9, 1996, worked like this. They sent single rubidium atoms prepared in circular Rydberg states with principal quantum numbers around 50 to 51 through a superconducting microwave cavity. The cavity was cooled to near absolute zero and contained a coherent electromagnetic field of approximately 3.1 photons. When a rubidium atom passed through the cavity, the atom-cavity interaction created a superposition. The cavity field existed in two coherent states simultaneously, two states with different phases, like a Schrödinger cat that is both alive and dead. Except this was a Schrödinger cat made of photons in a box, and for the first time in history, physicists could watch it die. They sent a second probe atom through the cavity at variable delays after the first atom. By measuring the correlations between the two atoms, they could reconstruct the quantum state of the cavity field at different moments in time. And what they saw was the coherence, the delicate phase relationship between the two superposed states decaying to zero, smoothly, predictably, exactly matching Zurek's theoretical predictions. Haroche himself acknowledged the connection explicitly. In his Nobel biographical lecture, he wrote, a 1991 paper in Physics Today by Wojciech Zurek, which very clearly describes superpositions of harmonic oscillator states, and their decoherence played an important role in this context. When reading this paper, we realized that we were in a position to observe these effects in the laboratory. I want to pause on that sentence. Haroche read Zurek's paper and realized he could test it. Zurek's paper summarized the theoretical framework, but the theoretical framework was theirs. Published 21 years before Zurek's review. Published 26 years before Haroche's experiment. The chain of credit runs Ze to Zurek to Haroche, but the chain of recognition runs Haroche to Zurek and then stops. Ze is the ghost in the machine. By the time Haroche won the Nobel, his team had improved their cavities to photon storage times of 0.13 seconds, with quality factors of 4 times 10 to the 10th. In 2008, they published in Nature, volume 455, page 510, a direct visualization of Schrödinger cat states decohering through Wigner function tomography. You could literally watch the quantum state of the cavity field lose its catness and become classical. The images are among the most beautiful in experimental physics, and they are images of something dying. They are images of quantum possibility being murdered by the environment. David Wineland's team at NIST contributed the complementary evidence. They created Schrödinger cat states of single beryllium ions separated by 80 nanometers and published the results in Science, volume 272, page 1131, in 1996. They then demonstrated that decoherence rates scale exactly as theory predicted, published in Nature, volume 403, page 269, in 2000. The 2012 Nobel Prize in Physics went to Haroche and Wineland for groundbreaking experimental methods that enable measuring and manipulation of individual quantum systems. The citation did not mention Zay. The press coverage did not mention Zay. The popular accounts of the prize did not mention Zay. A commenter on Peter Woit's blog wrote after Zay's death, "Surely he was deserving of the Nobel Prize for proposing decoherence, which, as he said, has now been clearly experimentally confirmed." And now I want to correct something you probably believe. If you have watched any YouTube video about quantum mechanics, you almost certainly believe that Schrödinger proposed his cat thought experiment to illustrate how quantum mechanics works. That the cat being alive and dead simultaneously is a feature of quantum mechanics, something to marvel at, something to use as a metaphor for quantum weirdness. That is wrong. Schrödinger designed the cat thought experiment as an attack. He was not illustrating quantum mechanics. He was attacking the Copenhagen interpretation. He was saying, look, if you take your interpretation seriously, if you really believe that observation collapses the wave function and that superposition is real until observation occurs, then you have to accept that a cat can be simultaneously alive and dead. And since that is obviously absurd, your interpretation must be wrong. Schrödinger was making fun of the idea. He was constructing a reductio ad absurdum, and somehow, over the decades, the attack was transformed into an advertisement. The thing that was supposed to show the absurdity of the Copenhagen interpretation became the icon of quantum mechanics itself. That is not a failure of physics. That is a failure of science communication so complete it verges on comedy. But the experiments that really killed the consciousness interpretation were the ones that specifically tested whether human minds make any difference at all. In 2012, Xiaosong Ma, Anton Zeilinger, and colleagues at the University of Vienna published Experimental Delayed Choice Entanglement Swapping in Nature Physics, Volume 8, Issue 6, pages 479 through 484. This experiment realized a thought experiment originally proposed by Asher Perez in 2000. 4 photons were created in 2 entangled pairs. Alice and Bob measured photons 1 and 4. A third party, called Victor, could choose to entangle or not entangle photons 2 and 3. The critical detail: Victor's choice was made 35 nanoseconds after photons 1 and 4 had already been detected. And Victor's choice was made not by a human mind, but by a quantum random number generator, a machine. No consciousness, no intention, no awareness. The results were identical to what quantum mechanics predicts. The machine's random choice produced exactly the same quantum correlations as a human choice would have. Consciousness of the decision maker proved irrelevant. But if that were the only experiment, you might argue it was not definitive. So the physics community went bigger, much bigger. On November 30th, 2016, more than 100,000 people around the world sat down at their computers and played a video game. The game was designed to generate random binary choices, zeros and ones, as quickly as possible. Each player tried to be as unpredictably random as they could. Over the course of the experiment, they generated 97,347,490 random bits, streamed in real time at over 1,000 bits per second to 13 experiments across 12 laboratories on 5 continents: Brisbane, Shanghai, Vienna, Rome, Munich, Zurek, Nice, Barcelona, Buenos Aires, Concepcion, Boulder. The experiments used entangled photons, single atoms, atomic ensembles, and superconducting devices. The human-generated random bits were used to choose measurement settings, the role traditionally assigned to the observer. The results were published in Nature, volume 557, pages 212 through 216 in 2018, under the title Challenging Local Realism with Human Choices. The combined result, a p-value of 1.02 times 10 to the negative 16th, Bell inequality violations observed across all experiments. The Bell parameter S exceeded 2, the local realist bound. And here is the result that matters for our purposes. 100,000 human minds, generating nearly 100 million random choices, produced exactly the same quantum correlations as machine-generated random numbers. Exactly the same. If consciousness played any special role in quantum mechanics, if human awareness affected quantum outcomes in any way that differs from a random number generator, you would expect to see some difference, some signature, some trace. There was none. The p-value was 10 to the negative 16th. That means the probability of getting this result by chance, if consciousness did make a difference, is less than 1 in 10 quadrillion. The consciousness interpretation was not just wrong. It was tested rigorously by 100,000 people across 5 continents. And it was found to be wrong with a statistical certainty that physicists describe as beyond any reasonable doubt. But here is where the story takes a turn that I still do not know how to think about. Every one of these experiments confirms that decoherence works. The environment monitors quantum systems and selects outcomes. But that word, monitors, is doing more work than anyone wants to admit. Because if you ask what the environment is actually doing when it monitors, the answer is exchanging information. And if you then ask what information is, physically, you will find that the question has no answer. The physics community has spent 4 decades confirming that decoherence is real, that the environment is the observer, that consciousness is irrelevant. And in all that time, nobody has managed to explain what the environment is doing in terms that do not invoke a concept. Information that is just as undefined as the consciousness it replaced. And there was one more experiment I need to tell you about, because it made the mechanism viscerally visible. In 2004, Lucia Hackermüller and Markus Arndt at the University of Vienna published a paper in Nature, volume 47, pages 711 through 714, titled Decoherence of Matter Waves by Thermal Emission of Radiation. They took C70 fullerene molecules, buckyballs, 70 carbon atoms arranged in a hollow sphere with a mass of 840 atomic mass units. They heated these molecules with a laser to temperatures exceeding 3000 Kelvin and sent them through a Talbot-Lowe interferometer. At moderate temperatures around 900 Kelvin, full quantum interference was observed. These are molecules made of 70 atoms, and they were behaving as waves, producing interference fringes, exhibiting quantum behavior. As the temperature rose, the molecules began emitting thermal photons. Each photon carried which path information. Each photon that escaped into the environment was an act of observation by the environment, and the interference pattern smoothly degraded. At 3000 Kelvin, complete decoherence, no interference, classical behavior. The quantitative agreement with the Juice-Set theory from 1985 was exact. The visibility of the interference fringes dropped precisely as the decoherence model predicted. The authors concluded Decoherence by emission of thermal radiation is a general mechanism that should be relevant to all macroscopic bodies. You could watch quantum mechanics die. You could watch a 70-atom molecule lose its quantum nature in real time as the environment gradually learned which path it took. Not because a conscious mind looked at it, because photons escaped. That is all. Photons left the molecule and carried information into the environment. And that was enough to destroy the superposition. The environment does not care about your mind. The environment does not need your mind. The environment does not wait for your mind. The environment is already watching, already measuring, already selecting with a thoroughness and a speed that makes human observation look like an afterthought. You are not the observer the universe is responding to. You never were. But that should have been the end of the consciousness story right there. The experiments are definitive. The theory is confirmed. The numbers match. The case is closed. Except the case is not closed, because decoherence, for all its experimental triumph, does not actually solve the measurement problem. And the people who know this best are the people who developed decoherence. Stephen Adler published a paper in 2003 in Studies in History and Philosophy of Modern Physics, Volume 34, pages 135 through 142, with the blunt title, Why Decoherence Has Not Solved the Measurement Problem, a response to P.W. Anderson. P.W. Anderson was a Nobel laureate. He had declared the measurement problem solved. Adler showed he was wrong. The technical issue is something called the and/or problem, and it goes like this. Decoherence converts a quantum superposition into a diagonal density matrix. That means it converts a situation where the cat is in a superposition of alive and dead into a situation that looks like a classical probability distribution, 50% alive, 50% dead. That seems like progress. The quantum weirdness is gone. You have classical probabilities. But there is a crucial distinction that most people miss. The diagonal density matrix produced by decoherence is what physicists call an improper mixture. It arises from tracing over the environment, from averaging over all the environmental degrees of freedom you cannot access. It is not a proper mixture, which would mean the cat was always either alive or dead, and you simply did not know which. The improper mixture does not represent your ignorance of a pre-existing definite state. It represents the fact that the cat, the apparatus, and the environment are all entangled together, and when you ignore the environment, the cat looks classical. As the Stanford Encyclopedia of Philosophy puts it, while decoherence does explain why we do not observe superpositions of measurement results, it does not explain why we do observe measurement results in the first place. Read that again. Decoherence explains why you never see the cat alive and dead simultaneously. It does not explain why you see the cat alive rather than dead. It does not explain why one specific outcome occurs. It does not explain the transition from and to or, from the cat is alive and dead to the cat is alive or dead. That transition, which is the actual measurement problem, remains completely unsolved. Sabine Hossenfelder, citing a 2016 survey of approximately 1,200 physicists, noted that 29% of respondents erroneously believe decoherence solved the measurement problem. She called the transition from quantum probabilities to classical actuality the biggest unsolved mystery in all of fundamental physics. Think about that number, 29%. Nearly a third of physicists think the problem is solved. It is not solved. The people who developed decoherence know it is not solved. Zurek knows it. Serge knew it. Serge embraced the Everett many worlds interpretation specifically because he understood that decoherence alone is not enough. In many worlds, you do not need to explain why one outcome occurs because all outcomes occur. The universe splits. Decoherence explains why the branches do not interfere with each other, but you still need the interpretation. Decoherence is the mechanism, it is not the explanation. And John Bell, who understood the foundations of quantum mechanics better than almost anyone who ever lived, saw the deeper problem before anyone else. In his 1981 paper, Quantum Mechanics for Cosmologists, and later, in his devastating 1990 essay Against Measurement, published just before his death, Bell asked a question that cuts through every evasion and every comfort. Was the wave function of the world waiting to jump for thousands of millions of years until a single-celled living creature appeared? Or did it have to wait a little longer for some better qualified system with a PhD? Bell was mocking the consciousness interpretation. But his deeper point applies equally to decoherence, because if you replace consciousness with information transferred to the environment, you still have to answer what counts as the environment, what counts as information transfer. Where exactly does the boundary between system and environment go? And who or what decides? The consensus flip is coming. I want to survey the major interpretations of quantum mechanics, because when you see what they agree on and what they disagree on, the real shape of the problem becomes clear. The Copenhagen interpretation says the wave function is a tool for calculating probabilities, and the question of what happens between measurements is meaningless. Many worlds says the wave function is real, and every outcome occurs in a branching universe. Bohmian mechanics says particles have definite positions guided by a pilot wave, and the wave function is real. GRW, Gerardi-Rimini-Weber, says the wave function collapses spontaneously at random, modified by a new physical constant. Cubism says quantum states represent an agent's beliefs and probabilities are personal. Relational quantum mechanics says quantum states are relative to the observer, and there is no observer-independent reality. They disagree about everything. They disagree about whether the wave function is real. They disagree about whether particles have positions. They disagree about whether the universe splits. They disagree about whether probability is objective or subjective. They disagree about whether there is an observer-independent reality. But they all agree on one thing. Every single one of them, without exception, consciousness is not the relevant variable. Not one major interpretation of quantum mechanics assigns a special physical role to conscious awareness. Not Copenhagen, not many worlds, not Bohm, not GRW, not cubism, not relational QM. The one thing that every physicist who has thought seriously about quantum foundations agrees on, regardless of their interpretation, is that your mind does not collapse the wave function. That was settled. Experimentally, theoretically, and philosophically. And you were never told. You were never told because the consciousness version makes better television, because it sells books, because it fills seminar rooms, because it gives people the flattering sense that their minds are cosmically important, and because the replacement, the actual answer, is deeply uncomfortable. Not because it is complex, it is not complex, but because it leads somewhere that nobody wants to go. The replacement says, Information is what matters. The environment collects information about quantum systems, and that collection of information is what destroys superpositions, what selects outcomes, what creates the classical world you perceive. Information is the currency of reality. Information is what determines what is real. And nobody can tell you what information is. We are approaching the bottom now, and the bottom looks exactly like the top. The mystery has the same shape it had before they removed consciousness. They just gave it a different name. John Archibald Wheeler spent the last 3 decades of his life trying to articulate what he meant by that word. Wheeler, remember, had mentored Zurek. He had championed Hugh Everett's many worlds interpretation and then distanced himself from it. He had co-edited the canonical anthology with Zurek. He had witnessed the entire arc of the Decoherence program from inside. And at the end of it all, he arrived at something more radical than any of it. At a Santa Fe Institute conference in 1989, Wheeler made a declaration that has echoed through physics ever since. He said, "It from bit." Otherwise put, every it, every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, its very existence entirely, even if in some contexts indirectly, from the apparatus elicited answers to yes or no questions, binary choices, bits. This was published as Information, Physics, Quantum, the Search for Links in the Proceedings of the Third International Symposium on Foundations of Quantum Mechanics in Tokyo, 1989, pp 354 through 368. Read that quote again. Every particle, every field of force, even space-time itself, derives its existence from information, not from matter, not from energy, not from forces or fields or wave functions, from bits, from yes or no answers, from the binary registration of information. Wheeler told Jeremy Bernstein in 1985, "I do take 100% seriously the idea that the world is a figment of the imagination." He was not being whimsical. He was being precise. His participatory universe held that reality is not a pre-existing stage on which measurements are performed. Reality is created progressively by the act of measurement, not by consciousness, but by the registration of information. He devised an analogy that captures the idea. In the normal game of 20 questions, the group agrees on a secret object while the guesser leaves the room. The guesser comes back and asks yes or no questions. In Wheeler's version, the surprise version, no object exists until the questioning begins. Each answer must be consistent with all previous answers, but the object is not determined until the questions created. The questions are not discovering a pre-existing reality. The questions are constructing reality as they go. And the irony is staggering. Wheeler, who had not supported Serge's Decoherence program, who had given his institutional backing to Zurek instead, ended his career proclaiming that information, the very currency of decoherence, is the foundation of reality. He traced an arc from everything is particles in the 1930s through 50s, through everything is fields in the 50s through 70s, to everything is information in the 80s through 2008 when he died. But Wheeler's proclamation, for all its poetry, leaves the same question unanswered. What is information? Rolf Landauer at IBM gave the concept its sharpest physical teeth. In his 1961 paper, Irreversibility and Heat Generation in the Computing Process, published in the IBM Journal of Research and Development, Volume 5, Pages 183 through 191, Landauer proved that erasing one bit of information requires a minimum energy dissipation of kT times the natural logarithm of 2. At room temperature, 300 Kelvin, that works out to approximately 2.87 times 10 to the negative 21 joules. Erasing information produces heat, not metaphorically. Physically, information is not an abstract bookkeeping device floating above the physical world. It is embedded in the physical world. It has thermodynamic consequences. Destroy a bit and the universe heats up by a tiny amount, by an amount that is calculable and specific and non-negotiable. This was experimentally confirmed for the first time by Barut et al. In Nature in 2012, using a colloidal particle in an optical double-well potential. They measured the heat dissipated when a single bit was erased and confirmed Landauer's minimum. A 2016 experiment measured energy dissipation from a nanomagnetic bit flip at 0.026 electron volts, approximately 4.2 times 10 to the negative 21 joules, only 44% above the Landauer minimum. Information is not an abstraction, it bites. But Landauer's principle, powerful as it is, tells you what information does, not what information is. Shannon information, formalized by Claude Shannon in 1948, is a mathematical quantity measuring uncertainty reduction. It is defined by probability distributions. It is purely abstract. You can apply it to English text, to DNA, to radio signals, to anything that carries structure. It does not care about the physical substrate. A bit is a bit, whether it is stored in a transistor, a neuron, a photon polarization, or a pattern of ink on paper. Quantum information adds entanglement and the no-cloning theorem, but does not resolve the ontological question. The Bekenstein bound, derived by Jacob Bekenstein in 1981, proves that the information content of any finite region of space is finite, approximately 10 to the 69th bits per square meter of bounding surface. The holographic principle, developed by Gerard 't Hooft in 1993 and Leonard Susskind in 1995, shows that all the information about a three-dimensional region can be encoded on its two-dimensional boundary. The ER equals EPR conjecture, proposed by Juan Maldacena and Leonard Susskind in 2013, suggests that quantum entanglement literally creates the geometry of space-time. These are not speculations. These are published, peer-reviewed results with precise mathematical formulations, and they all point in the same direction. Information is not riding on top of physics. Information might be what physics is made of. Seth Lloyd at MIT published Computational Capacity of the Universe in Physical Review Letters in 2001. He calculated that the universe has performed no more than 10 to the 120th elementary logical operations since the Big Bang, on approximately 10 to the 90th bits of information. His 2006 book, Programming the Universe, declared, "All interactions between particles in the universe convey not only energy, but also information." In other words, particles not only collide, they compute. The universe is a computer. That sounds like a metaphor. It is not. Lloyd's paper contains rigorous bounds derived from quantum mechanics and general relativity. The computational capacity of the universe is finite, calculable, and constrained by fundamental physics. The universe cannot have computed more than 10 to the 120th operations, because that is how many distinguishable quantum states have been available since the Big Bang. That is not a metaphor. That is a theorem. Konrad Zuse, who built the world's first programmable computer, the Z3, in 1941, published Rechnungsraum, Calculating Space, in 1969. He argued the universe is a cellular automaton. Edward Fredkin coined the term digital physics. The Simons Foundation launched the IT from Qubit collaboration in 2016, funding hundreds of researchers across more than 18 laboratories to investigate how space-time emerges from quantum entanglement. The Ryu-Takayanagi formula, published in 2006, equates the entanglement entropy of a quantum system with the area of a geometric surface in gravitational space-time. As Tadashi Takayanagi stated, the microscopic structure of space-time in gravity may be regarded as the collection of entangled qubits. Space-time itself might be made of information. The fabric of reality, the stage on which everything you have ever experienced has taken place, might be woven from entanglement, from correlations, from bits, and the thing that elevated information from an interesting concept to a sacred principle was the black hole information paradox. In 1974 through 76, Stephen Hawking showed that black holes radiate thermally and eventually evaporate. The radiation is thermal, meaning it carries no information about what fell into the black hole. When the black hole evaporates completely, the information about everything that ever fell in appears to be destroyed. But quantum mechanics says information cannot be destroyed. The evolution of quantum states must be unitary, reversible. If you know the present perfectly, you can in principle reconstruct the past. Hawking's calculations said, no, you cannot. The black hole eats the information and the radiation gives you nothing back. This violated unitarity, and it launched a war that consumed theoretical physics for 3 decades. Hawking bet John Preskill, a Caltech physicist, that information was truly lost. Leonard Susskind fought what he later called the Black Hole War. The stakes were enormous. If information could be destroyed, quantum mechanics was incomplete. If information could not be destroyed, general relativity was incomplete. One of the 2 pillars of modern physics had to give. On July 21, 2004, at a conference in Dublin, Hawking conceded. He stated that the ADS/CFT correspondence, a mathematical duality between certain quantum field theories and gravitational theories, had shown there is no information loss. He presented Preskill with an encyclopedia, a symbolic gesture meaning that information can be retrieved at will. The 2019 derivation of the page curve, using the island formula by Pennington and by Almhiri, Engelhardt, Marolf and Maxfield, provided further evidence. The resolution cemented information conservation as a principle comparable to energy conservation. Information cannot be created or destroyed. It can be scrambled beyond recognition. It can be spread across the entire environment. It can be encoded in ways that are practically impossible to decode. But it cannot be destroyed, ever. Think about what that means. Every quantum state that has ever existed still exists, in principle, encoded somewhere in the correlations of the environment. Every photon that has ever bounced off your face carries information about you into the universe. Every breath you have ever taken scattered molecules that carry your chemical signature. The environment does not just observe. The environment remembers. The universe is not forgetting anything. It is recording. everything. And now we can see the shape of the replacement clearly. Consciousness was removed from quantum mechanics and replaced by information. The environment observes quantum systems by collecting information about them. This collection of information is what destroys quantum superpositions and creates the classical world. The process is called decoherence, and it is experimentally confirmed to extraordinary precision. But information has no physical definition. It has thermodynamic consequences, per Landauer. It has mathematical structure, per Shannon. It appears to be conserved, per the resolution of the black hole information paradox. It may constitute the fabric of spacetime itself, per holography and ER equals EPR, but nobody can tell you what it is in the way that you can tell someone what an electron is, or what a photon is, or what a quark is. Chris Fields has pointed out something that makes this even more uncomfortable. He wrote that decoherence is, after all, an observer-dependent effect. An observer who could monitor every degree of freedom in the universe would not expect to see any decoherence. Decoherence is what happens when you cannot track everything, when you are forced to average over the degrees of freedom you cannot access. The boundary between system and environment, the boundary that determines what decoheres and what does not, is set by the observer's limitations, which means the classical world, the world you experience, the world of definite objects with definite positions moving along definite trajectories, is not a property of the universe. It is a property of your ignorance. It is what the universe looks like when you cannot see all of it. And the thing that determines how much you can see, the thing that determines where the boundary falls between system and environment, between quantum and classical, between and or, is information. Specifically, it is the information available to you. We replaced consciousness with information, and then we discovered that information in quantum mechanics is relational. It depends on who has access to what, which means that the classical world is not objective. It is perspectival. It depends on the observer's information. The parallels are not subtle. Consciousness is subjective. Information access is perspectival. Consciousness is undefined. Information is undefined. The consciousness interpretation said, "Your mind determines what is real." The information interpretation says, "Your information determines what is real." We walked in a circle. We arrived back where we started. We just used different words. And now I want to come back to the people, because the human cost of this story is not over. Zurek extended decoherence into something called quantum Darwinism, formally published in Nature Physics, Volume 5, pages 181 through 188, in 2009. Standard decoherence explains why superpositions disappear. Quantum Darwinism explains why we all agree on what reality looks like. The environment does not merely absorb coherence, it creates redundant copies of information about pointer states. Scattered photons each carry an imprint of a dust grain's position. Multiple observers can independently access different fragments of the environment and arrive at the same information without disturbing the system. Zurek said, "The environment is like a big advertising billboard which floats multiple copies of the information about our universe all over the place." Objectivity in quantum Darwinism is not a property of reality. It is a property of redundancy. We agree on what is real because the environment broadcasts the same information to all of us. Reality is not something that exists and then gets observed. Reality is something that gets selected by the environment and then advertised, copied, broadcast, distributed. The universe is not a stage, it is a newsroom. And the environment is the editor deciding which stories get published. 3 independent experiments confirmed quantum Darwinism's predictions in 2018 through 2019, including a test using nitrogen vacancy centers in diamond, published in Physical Review Letters, Volume 123, page 140. 402. A 2025 experiment using superconducting circuits, published in Science Advances, provided further confirmation. The environment selects what gets to be real and then advertises it. That sentence should sit with you for a moment, because it means that the classical world, everything you see and touch and measure, is not the universe. It is the universe's press release. It is the version of events that survived editorial review by the environment. And the editor has no consciousness, no purpose, no agenda. The editor is just physics, just interactions, just information flowing from one system to another. And now the final turn. H. Dieter Zeh maintained a personal website, Decoherence.de. For years, he continued writing and publishing until weeks before his death. He posted on Peter Voigt's blog, Not Even Wrong, just 3 weeks before he died. On April 15, 2018, while on holiday in the Black Forest, he died. He was 85 years old. By then, the Serge term decoherence returned. 1,477 papers on the Arxiv quantum physics preprint server alone, a field he founded alone, in isolation against active institutional opposition. Springer published a memorial volume in 2002, From Quantum to Classical, Essays in Honor of H. Dieter Zeh, edited by Klaus Kiefer, his former PhD student. Kiefer wrote in his obituary, "The first experimental tests of decoherence were performed in 1996 and later, notably by the groups of Haroche in France and Wineland in the US, Nobel Prize winners of 2012. Zeh knew, better than anyone, that decoherence did not solve the measurement problem. He embraced the many worlds interpretation precisely because he understood the and/or gap. He understood that decoherence explains why branches do not interfere, but you still need to explain why branches exist. He was not naive about the limits of his own discovery, but the discovery itself, the insight that the environment is the observer, that consciousness is irrelevant, that the classical world emerges from quantum entanglement with the environment. That insight has been confirmed by every experiment ever designed to test it. And the man who discovered it was punished for seeing clearly in a time that demanded obedience. There is a pattern in physics, and the pattern has nothing to do with the quality of the ideas. Bohm was exiled. De Broglie was silenced. Everett was ignored until after his death. Bell was recognized too late, and Zeh was marginalized for the crime of being right before the field was ready to hear it. The irony that closes this story is almost too perfect to be real. Zeh proved that consciousness is irrelevant to quantum mechanics. He showed that the environment, not the mind, determines what is real, but his own career was determined not by the environment of evidence and experiment. It was determined by the conscious decisions of powerful men who chose to suppress uncomfortable truths because confronting them was professionally inconvenient. The man who proved consciousness does not matter in physics spent his life experiencing exactly how much consciousness, specifically the conscious biases of gatekeepers, determines what counts as knowledge. Wheeler who gave his backing to Zurek rather than Serge, who helped build the institutional framework that made decoherence respectable only after someone other than Serge championed it, wrote in his later years with characteristic optimism, "Surely someday we will grasp the central idea of it all as so simple, so beautiful, so compelling that we will all say to each other, 'Oh, how could it have been otherwise?' That day has not arrived. What has arrived is this. You are a pattern of information. You are being monitored by an environment you cannot see, at a speed you cannot comprehend, through a process that has no name and no definition. The environment is selecting what you get to experience as reality. It is broadcasting that selection to every observer with access to the same environmental fragments. And it is doing this not because it has a purpose, not because it is conscious, not because it cares, but because that is what interactions between quantum systems do. They exchange information, they create correlations, they destroy superpositions, they select outcomes. The thing doing the selecting has no consciousness, it has no mind, it has no intention. It is just physics, but it is physics built on a foundation that nobody can define. You used to call it consciousness. Then they told you it was never consciousness. They told you it was information, and information is real. Landauer proved it generates heat. Bekenstein proved it has limits. Hawking and Preskill bet their reputations on whether it can be destroyed. The entire edifice of modern theoretical physics, from holography to quantum error correction to the emergence of space-time, is built on the assumption that information is fundamental. But what it actually is, in the same way that a photon is a quantum of the electromagnetic field and an electron is a lepton with charge negative 1.6 times 10 to the negative 19th coulombs. What information is in those terms? Nobody knows. The measurement problem is not solved. The quantum to classical transition is not explained. The and/or gap is still open. Decoherence tells you why you never see a cat alive and dead. It does not tell you why you see a cat alive. It does not tell you why one outcome out of all the outcomes encoded in the universal wave function is the one you experience. And the thing that was supposed to answer that question, the thing that was supposed to replace consciousness, the thing that physics elevated to the status of a fundamental principle, remains undefined. You were told your mind mattered. That was wrong. You were told it was replaced by something we understand. That was also wrong. The replacement is real. The replacement works. The replacement has been confirmed by every experiment ever designed to test it. And the replacement is a word that nobody can define, operating through a mechanism that nobody can fully explain, producing a classical world that may be nothing more than a projection of your ignorance onto a quantum reality that does not, at the deepest level, contain the definite objects you think you see. The environment is watching. The environment is selecting. The environment is deciding what gets to be real. And the environment is doing all of this through the exchange of information. And information is the new consciousness. It is the thing we invoke when we need the equations to work, the thing we cannot remove without the theory collapsing, the thing that is everywhere and fundamental and absolutely essential, and the thing that nobody in 94 years of trying has been able to tell you what it actually is. Serge saw it first. He saw it in 1970. He tried to tell them. They told him to let sleeping dogs lie. He let the dogs lie. The dogs, it turned out, were not sleeping. They were watching They had been watching the whole time, and they are watching now. I want to stay with von Neumann for a moment longer, because the weight of what he did in 1932 has never been properly communicated. This was a man who could multiply 8-digit numbers in his head as a child. His colleagues at the Manhattan Project described his computational ability as superhuman. Edward Teller once said that von Neumann's brain indicated a new species of human. And this brain, the most powerful analytical mind of the 20th century, looked at quantum mechanics and found a crack. Not in the mathematics. The mathematics was fine. The crack was in what the mathematics said about reality. Von Neumann did not stumble upon the measurement problem by accident. He derived it. He proved with mathematical rigor that if quantum mechanics is a complete description of nature, then the transition from superposition to definite outcome cannot happen within quantum mechanics. Something outside the formalism must intervene. He called this process 1. And the thing about process 1 is that nothing in the equations tells you when it should happen. Nothing in the equations tells you where the boundary is between the quantum world and the classical world. Nothing in the equations tells you what triggers the transition. The equations just say, evolve smoothly forever. And then reality says, no, sometimes things are definite. The gap between those two statements is the measurement problem. And it has not been closed, not in 1932, not in 22,006, not by anyone. What happened next was a social process, not a scientific one. The physics community, led by Bohr and Heisenberg and the Copenhagen school, decided that the measurement problem was not a problem. They declared that asking what happens during measurement is meaningless. The quantum formalism gives you probabilities. You get outcomes. Do not ask how. Do not ask why. Shut up and calculate. That phrase, shut up and calculate, is usually attributed to Richard Feynman, though the actual origin is disputed. What is not disputed is the culture it describes. For decades, asking foundational questions about quantum mechanics was career suicide. John Bell, who would later prove the most important theorem in all of quantum foundations, was told by his PhD supervisor to work on something useful. Bell had to do his foundational work in his spare time at CERN, while his day job involved particle accelerator design. This is the context in which Zay's discovery must be understood. He did not publish into a vacuum of interest. He published into an active culture of suppression. Foundational questions were taboo. The Copenhagen interpretation was not just dominant, it was enforced. I think it is worth dwelling on the culture of silence that Zet was publishing into, because understanding the culture tells you why the wrong version of quantum mechanics persisted for so long. In the late 1920s, a group of physicists centered around Niels Bohr in Copenhagen essentially declared victory over the measurement problem. They did this not by solving it, but by redefining it. Bohr argued that quantum mechanics is complete, that the wave function is a computational tool, not a description of reality. That asking what happens between measurements is meaningless, that the classical world and the quantum world are separate domains and the boundary between them is irreducible. This became known as the Copenhagen interpretation. And the way it was enforced was not through evidence or argument, it was through social pressure. Werner Heisenberg wrote in 1958 that the Copenhagen interpretation was unanimously accepted by all physicists. That statement was false. It was false at the time he wrote it. De Broglie had proposed pilot wave theory in 1927. Einstein never accepted Copenhagen. Schrödinger designed his cat experiment specifically to attack it. Bohm revived pilot wave theory in 1952, and yet Heisenberg wrote, unanimously accepted, and the statement went unchallenged for decades. The mechanism of enforcement was career pressure. If you worked on foundational questions, you were considered unserious. If you questioned the measurement problem, you were a philosopher, not a physicist. If you proposed an alternative interpretation, you were eccentric at best and dangerous at worst. David Bohm, who in 1952 published a fully deterministic, empirically equivalent alternative to Copenhagen, was not just scientifically dismissed, he was politically persecuted. Accused of communist sympathies during the McCarthy era, he lost his position at Princeton, had his passport confiscated in Brazil, and was effectively exiled from mainstream American physics for over a decade. His physics was correct, his politics were wrong, and the two were deliberately conflated by people who wanted to discredit his work without engaging with it. When J. Robert Oppenheimer was asked about Bohm's interpretation, he reportedly called it juvenile deviationism, a phrase borrowed from Stalinist political language. The irony of using Stalinist terminology to suppress scientific dissent appears to have been lost on him. John Bell, working at CERN in the 1960s, had to pursue his foundational work as a side project. His day job was accelerator physics. His real work, the work that led to Bell's theorem in 1964, arguably the most important result in all of quantum foundations, was done in his spare time. Because working on quantum foundations was not a career path. It was a career risk. This is the world that Serge published into in 1970, a world where the foundational question had been declared solved by fiat, where questioning the declaration was career suicide, where the people who controlled hiring and funding and publication had a vested interest in maintaining the status quo. Not out of malice, out of comfort, out of the perfectly human desire to not reopen questions that had been settled, to not disturb the consensus that had allowed physics to make extraordinary progress in applications while ignoring the foundations. And the tragic consequence is that the wrong version, the consciousness version, the version that was never the mainstream physics position, leaked out of the professional disagreement and into popular culture, because the professionals were not talking about foundations, because the professionals had declared the question closed, because the professionals were not writing popular books about the measurement problem. And into that silence, the consciousness interpretation, supported by Wigner's famous essay and amplified by the New Age movement of the 1970s and 80s, filled the vacuum. The public believed in consciousness causes collapse, not because the evidence supported it, but because nobody was publicly contradicting it. The physics community was silent. The popular writers who were not silent were the ones pushing the consciousness version. And the consciousness version, with its flattering implication that human minds matter cosmically, spread through culture unchecked. Serge tried to break the silence. He paid the price, and the silence continued for another 20 years until Zurek, protected by Wheeler's name, made decoherence respectable. You deserve to know that history, because it explains why you believe what you believe about quantum mechanics. It was not your fault. You were never given the correct version. The correct version was available in the technical literature, but the people who should have communicated it were professionally incentivized to stay silent. And the people who did communicate, the popular science writers and documentary producers, communicated the wrong version because the wrong version was more dramatic, more flattering, and more commercially viable. That is not a conspiracy. It is worse. It is a system that produces the wrong outcome through no one's deliberate intention. Everyone was acting rationally within their incentives. The physicist stayed quiet because speaking up was career risk. The writers wrote consciousness because it sold. The audience consumed consciousness because it was all that was available. And the result was a population of scientifically curious people who believed something about quantum mechanics that was never the scientific consensus. You are the end product of a 70-year systemic failure in science communication. And the first step in correcting that failure is knowing that it happened. Now let me tell you about one more experiment, because it is the most recent and the most directly relevant to the question of whether the measurement problem has been solved. In 2002, a team at Griffith University in Australia published an experiment in Nature Physics that directly tested whether quantum coherence can exist at the level of organic molecules involved in biological processes. They studied the light harvesting complex in green sulfur bacteria, a photosynthetic antenna that transfers energy from absorbed photons to a reaction center with near-perfect efficiency. Previous experiments had claimed to see quantum coherence in these systems at physiological temperatures, leading to breathless headlines about quantum biology and quantum consciousness. The Griffith team showed that the previously observed signals were not quantum coherence, but classical vibrational noise. The quantum coherence, to the extent it existed, decohered in approximately 60 femtoseconds at physiological temperatures. 60 femtoseconds, 6 times 10 to the negative 14 seconds. The decoherence timescale was so fast that it could not possibly play any functional role in biological energy transfer. The classical noise had been masquerading as quantum coherence, and previous experiments had not been careful enough to tell the difference. This matters because it closed another door that consciousness enthusiasts had tried to open. If quantum coherence could persist in warm, wet biological systems, then maybe, the argument went, quantum effects could be relevant to brain function after all. Maybe Tegmark's calculation was wrong. Maybe consciousness really did have a quantum role to play. The Griffith experiment said, no, decoherence in biological systems is exactly as fast as Tegmark predicted. The brain is classical. Consciousness is classical. Whatever consciousness is, it does not operate through quantum coherence, because quantum coherence in biological matter at body temperature lasts for approximately 60 femtoseconds, and neurons operate on timescales roughly 10 billion times slower. 10 billion times slower. That is not a close call. That is not a, well, maybe in special circumstances kind of gap. That is the gap between a camera shutter and the age of the Roman Empire. So the question is truly settled, experimentally settled, with multiple independent experiments, multiple independent techniques across multiple decades, in multiple countries, by multiple research groups with no coordinated agenda. Consciousness does not collapse the wave function. The environment does, through information exchange, at speeds that make conscious observation a rounding error. And the thing that does the collapsing, the thing that drives decoherence, the thing that is exchanged between system and environment, the thing that is more fundamental than matter or energy or space-time, remains undefined. I want to acknowledge something before the end. I have been hard on the physics community in this script. I have talked about suppression, about careerism, about the culture of silence. And all of that is true, but I want to be fair. Decoherence is one of the greatest intellectual achievements of the 20th century. Serge's insight was correct, and profound. Zurek's formalization was elegant and necessary. The experimental program that confirmed decoherence is one of the most beautiful sequences of experiments in all of physics. Haroche's Wigner function tomography images are works of art. The Big Bell test was an act of collective human creativity that deserves more attention than it has received. And the ongoing work on information and quantum foundations, from quantum Darwinism to holographic entanglement to the id from qubit program, represents some of the deepest thinking that human beings have ever done about the nature of reality. The problem is not that physics failed. The problem is that science communication failed. The people doing the physics got it right. The people communicating the physics got it wrong. And the gap between the two, the gap between what physicists know and what the public believes about quantum mechanics, is one of the largest and most consequential gaps in all of science communication. That gap is what this video is about. Closing it, or at least narrowing it enough that you leave knowing something closer to the truth than what you arrived with. The truth is, consciousness was removed from quantum mechanics. The removal began in 1970 with Z, was formalized in 1982 by Zurek, was confirmed experimentally starting in 1996, and was tested with decisive statistical power in 2018 by 100,000 volunteers. The truth is, the replacement is information. The environment collapses superpositions by collecting information through physical interactions. This happens at speeds that dwarf any biological process. This has been measured, confirmed, and quantified. The truth is, decoherence does not solve the measurement problem. It explains why you do not see superpositions. It does not explain why you see one specific outcome. That question remains open. The truth is, information, the concept at the center of the replacement, has no agreed upon physical definition. It has thermodynamic consequences. It appears to be conserved. It may constitute space-time itself. But what it is, in physical terms, nobody knows. And the truth is, Zay saw all of this in 1970. He was punished for it. He was vindicated by experiment. He never received the recognition he deserved. And he died in the Black Forest on April 15, 2018, while the man who popularized his idea held a position at Los Alamos, while the men who confirmed his idea held Nobel Prizes, and while the popular understanding of quantum mechanics remained, stubbornly, incorrectly, fixated on the consciousness interpretation that his work had destroyed. The environment absorbed the information about his passing. The photons scattered. The thermal radiation carried his quantum state into the air, and the decoherence was immediate, as it always is, as it always has been, because the dogs were never sleeping, and they are watching now. And I want to be precise about what London and Bauer actually argued, because the popular version is a caricature. Their 1939 monograph was not a casual suggestion. It was a rigorous analysis within the framework von Neumann had established. They started with the entangled state of system, apparatus, and observer. They noted that the observer, unlike the apparatus, has a unique capacity. The observer can perform what they called an act of introspection. The observer can distinguish between knowing spin up and not knowing what the spin is. The apparatus cannot make this distinction. The apparatus is entangled with the system. The observer steps outside the entanglement through self-awareness. Now, stripped of philosophical nuance, this became consciousness collapses the wave function. But London was a serious philosopher of science who had studied under Haroche. His consciousness was not the vague New Age concept it later became. It was a technical term in phenomenology, referring to the intentional structure of awareness, the fact that consciousness is always consciousness of something. The subtlety was lost almost immediately. What survived was the headline, and the headline persisted for 80 years while the physics moved on. I am telling you this not because it is interesting background. I am telling you because it connects directly to why the consciousness version survived in popular culture long after it was abandoned in physics. The popular version was never the physics version. The popular version was a cartoon of the physics version. And the cartoon was so appealing, so flattering to human vanity, so perfectly designed to make you feel cosmically important, that it spread through culture like a virus, while the actual physics sat in technical journals that nobody outside the field was reading. Here is how mainstream the consciousness interpretation actually was, by the numbers. A 2011 poll of 33 physicists, mathematicians, and philosophers at a Quantum Foundations conference found that only 6%, 2 out of 33, endorsed the idea that the observer plays a distinguished physical role, such as consciousness-induced collapse, 6%. The popular version of quantum mechanics, the version that dominates YouTube and Netflix and airport bookstores, represents the view of 6% of the people who actually work on this problem. The other 94% knew it was wrong. They just did not have a YouTube channel. Niels Bohr himself, the architect of the Copenhagen interpretation, reportedly said as early as 1927, "It still makes no difference whether the observer is a man, an animal, or a piece of apparatus. Copenhagen requires a classical measuring apparatus. It does not require consciousness. A Geiger counter is enough. The conflation of Copenhagen with consciousness is not a simplification. It is an error, and it is an error that has been repeated so many times that correcting it feels like swimming against a river." But the story of Wigner's conversion deserves more space because it is one of the most intellectually honest moments in the history of physics. Wigner did not abandon the consciousness interpretation quietly or reluctantly. He thought about it for over a decade after Serge's paper appeared. He corresponded with Serge. He read Serge's subsequent publications, and when he changed his mind, he changed it publicly, in print, with attribution. The 1983 paper in which Wigner credited Serge was not a minor publication. It was a contribution to a NATO Advanced Science Institute volume. These are serious academic venues, and Wigner's statement was unequivocal. He wrote that the argument which convinced him came from Serge. He did not hedge. He did not share credit with Zurek. He pointed specifically to Serge. This matters because it tells you something about Wigner's character. He was a Nobel laureate. He had staked his reputation on the consciousness interpretation. Abandoning it meant admitting he had been wrong for over 20 years. And he did it openly, giving credit to a physicist that the rest of the community had marginalized. Wigner, whatever else you may think of his physics, had intellectual courage. He followed the argument where it led, even when it led away from his own published position. And then he was mostly forgotten for doing so. The popular narrative retained Wigner as the champion of consciousness. His conversion is one of the best-kept secrets in quantum foundations. Google Wigner quantum consciousness, and you will find 100 articles explaining his 1961 essay. You will find almost nothing about his 1983 retraction. Now I want to return to Zer's 1970 paper and walk through the physics more carefully, because the mechanism is both simpler and stranger than it sounds. Imagine a single electron in a superposition of spin up and spin down. In complete isolation, that superposition persists forever. The electron's quantum state evolves smoothly under the Schrödinger equation. Both possibilities coexist. No contradiction. Now let the electron interact with a single photon. The photon bounces off the electron. If the electron is spin up, the photon scatters in one direction. If the electron is spin down, the photon scatters in a different direction. After the interaction, the electron and the photon are entangled. The combined system is in a superposition of electron up photon left and electron down photon right. The electron is no longer in a pure superposition on its own. Its state has become entangled with the photon state. Now the photon flies away at the speed of light and is absorbed by a wall, or by the cosmic microwave background, or by a dust grain on the other side of the room. That photon is gone. It has joined the environment. And with it went the information about whether the electron was spin up or spin down. If you want to recover the full quantum superposition, if you want to see the interference between spin up and spin down, you need to also track the photon. You need to know where it went and what it did when it got there. But the photon has been absorbed by the environment, and the environment has 10 to the 20-something particles in every cubic centimeter of air alone. The photon's information has been diluted across a vast network of environmental correlations. In principle, the superposition still exists. The universal wave function still contains both spin up and spin down. But in practice, for any observer who cannot track every single environmental particle, the interference terms are gone. The off-diagonal elements of the density matrix have decayed to zero. The electron now behaves, for all practical purposes, as if it is in one definite state with classical probability. And here is the subtle part. This happened because of one photon, one interaction, one scattered quantum of light. Now imagine a macroscopic object, a dust grain. It is being bombarded by approximately 10 to the 18th photons per second at room temperature. Every single one of those photons scatters in a way that depends on the grain's quantum state. Every single one carries which state information into the environment. The grain is being measured 10 to the 18th times per second by the environment. It is being observed with a thoroughness that makes a room full of physicists look negligent. That is why the decoherence timescale for a dust grain is 10 to the negative 31 seconds. The environment resolves the quantum state in less time than it takes light to cross a distance 100 million times smaller than a proton. The environment is not subtle about observation. The environment is a surveillance state of incomprehensible proportions, and it has been operating since the Big Bang. This is what Zer saw. This is what was sitting in the equations all along. The environment is the observer. It was always the observer. The question was never, does the moon exist when nobody is looking at it? As Einstein famously asked. The answer is, something is always looking at it. The cosmic microwave background is looking at it. The sun's photons are looking at it. The neutrinos passing through it are looking at it. The gravitational field of the Earth is looking at it. The universe does not contain unobserved objects. The universe is a web of mutual observation so dense that true quantum isolation is almost impossible for anything larger than a few atoms. I want to come back to the people now, because I promised earlier that the biographical threads would return, and the thread that matters most here is the relationship between Serge and Zurek. Zurek arrived at the University of Texas in the mid-1970s as Wheeler's student. Wheeler, remember, had been involved in quantum foundations for decades. He had been Hugh Everett's thesis advisor for the many worlds interpretation in 1957. He had helped Everett publish, then distanced himself from the interpretation when it proved controversial. Wheeler understood the measurement problem deeply, and he understood the professional risks of working on it. When Zurek took up Decoherence as his research program, he had Wheeler's full institutional support. This meant he could publish in Physical Review D, not in Foundations of Physics. Physical Review D, the same journal that had been inaccessible to Serge. Wheeler's name on the collaboration meant that the physics community took Zurek seriously from the beginning. Zurek's approach differed from Serge's in one crucial respect. Serge was committed to the Everett many worlds interpretation. He saw decoherence as the mechanism that explains why the many worlds do not interfere with each other. For Serge, decoherence was a chapter in a larger story about the reality of the universal wave function. Zurek, by contrast, presented decoherence in interpretation-neutral language. He focused on the mechanism itself, on Einselection and pointer states, without committing to any particular interpretation of what it means. This made his work palatable to a broader audience. Copenhagen physicists could accept decoherence without accepting many worlds. Bohmians could accept it without abandoning hidden variables. Everyone could use the tool without buying the philosophy. This was politically smart and scientifically defensible, but it came at a cost. By stripping decoherence of its interpretive context, Zurek made it possible for physicists to use decoherence without confronting what it implies. And what it implies, as Serge always insisted, is that the universal wave function is real, that all branches exist, and that our experience of a single classical world is a consequence of our entanglement with a particular branch. Serge saw decoherence as evidence for many worlds. Serge presented it as evidence for nothing more than the mechanism itself. The field followed Zurek, and the interpretive question, the question of what decoherence means, was once again shelved. Once again, the uncomfortable implications were postponed. After Zurek's papers in 81 and 82, he moved to Los Alamos National Laboratory in 1984. As a J. Robert Oppenheimer Fellow, he became a laboratory fellow in 1996. He was elected to the National Academy of Sciences in 2024. His career is a model of institutional success. His 1991 Physics Today article brought decoherence to a general physics audience. His 2003 review in Reviews of Modern Physics, volume 17.5, page 715, is the definitive technical reference, with over 5,000 citations. Serge, meanwhile, continued working at Heidelberg. He continued publishing. He continued being right, and he continued being ignored by the broader physics community, cited in the technical literature as a historical predecessor, but rarely credited as the originator. The word predecessor does a lot of quiet damage in academic contexts. It positions Serge as someone who came before, someone who laid groundwork, someone who was in the right neighborhood but did not quite arrive at the destination. The truth is that Serge arrived at the destination in 1970. What he lacked was not insight, What he lacked was John Archibald Wheeler. Now I want to return to the experiments, because there is one detail in Haroche's work that I have not given proper weight. Haroche's team did not just observe decoherence, they observed decoherence as a function of the size of the Schrödinger cat state. By varying the number of photons in the cavity and the amplitude of the coherent field, they could create cat states of different sizes. Larger cat states, those with greater separation between the two superposed coherent states, decohered faster, exactly as the Zurek theory predicted. The decoherence rate scaled with the square of the distance in phase space between the two components of the superposition. This is not a vague, qualitative agreement. This is a quantitative prediction, derived from theory, confirmed by experiment to within experimental uncertainty. And by 2008, Haroche's team had achieved something even more striking. Using a technique called quantum state reconstruction, they produced images, actual color-coded plots, of the quantum state of the cavity field evolving in time. These Wigner function tomography images show a quantum superposition, two peaks in phase space with quantum interference fringes between them, gradually losing its fringes as the environment encroaches. The quantumness bleeds out of the system. The interference pattern fades. The two peaks remain, but the connection between them, the ghostly oscillation that says these are not two separate states but one quantum superposition, disappears. You are looking at the death of quantum mechanics in real time. And the killer is not consciousness. The killer is a few stray photons leaking through an imperfect mirror. I need to also tell you about an experiment that happened much more recently, and that you almost certainly have not heard of. In 2019, Massimiliano Proietti and colleagues at Heriot-Watt University published Experimental Test of Local Observer Independence in Science Advances. This experiment was an actual physical realization of a Wigner Friend scenario, extended by Kaslav-Bruckner's 2017 theoretical proposal. They created an entangled photon state and had two observers represented by photon measurements in separate labs, each register definite outcomes. They then tested whether the joint statistics of the outcomes were consistent with each observer having experienced a single definite result. The result was a violation of a Bell-like inequality with a statistical significance of 5 standard deviations. What this means, and this is genuinely difficult to process, is that if you assume all observers experience definite outcomes, and those outcomes are consistent with each other, the experimental statistics contradict the assumption. The experiment suggests that observer-independent facts may not exist, that what Wigner sees and what Wigner's friend sees may not be reconcilable into a single consistent story about what happened. This does not bring consciousness back into the picture. Both observers in the experiment were optical devices, not conscious minds. But it does suggest that the concept of an objective, observer-independent reality is more fragile than anyone expected. And it suggests that information, specifically the information available to different observers, determines not just what they see, but what is real for them. That result has not been widely reported. It should have made headlines. It did not. It was published in a top-tier journal with 5 sigma significance, and it was met with a collective shrug by the popular press, because the implication that objective reality may not exist is so profoundly unsettling that there is no comfortable way to package it for a general audience. The data has been sitting there since 2019. Nobody wanted to look at what it actually means. I want to address something directly now, because you may be feeling a certain skepticism. You may be thinking, if information is so fundamental and if so many papers and experiments support this, why have I never heard any of this presented in this way? Why does every quantum mechanics documentary still talk about consciousness? Why does every pop science book still frame the observer as a human mind? The answer is uncomfortable, and I am going to say it anyway. Consciousness sells. Information does not. Telling someone that their mind shapes reality is flattering. It makes the viewer feel important. It makes the viewer feel powerful. It connects quantum mechanics to New Age spirituality, to meditation, to the law of attraction, to the entire ecosystem of self-help content that promises you can manifest your desires by thinking the right thoughts. The consciousness interpretation, even though it was always a minority position in physics, is worth billions of dollars in books, seminars, retreats, and online courses. It is an industry. Telling someone that the environment collapses the wave function through information exchange is not flattering. It does not make you feel important. It does not make you feel powerful. It tells you that you are irrelevant to the process. That reality does not care about your awareness, that the universe was selecting outcomes for 13.8 billion years before a single conscious mind existed to notice. That is not a marketable message. So the marketable version persists, and the true version sits in Physical Review D and reviews of modern physics and nature physics, waiting for someone to tell it properly. And the true version, when you follow it to its end, is worse than the marketable version. Not because it diminishes you, because it replaces you with something that nobody understands. The consciousness interpretation, at least, had the virtue of invoking something you experienced directly. You know what consciousness feels like. You can point to it. You can say, this is the thing that collapses the wave function. The information interpretation invokes something you cannot point to. You cannot feel information. You cannot isolate it. You cannot hold it in your hand and say, this is the substance that determines what is real. And yet the physics says it is. The physics says that erasing one bit produces a minimum of kT-ln2 joules of heat. The physics says that the information content of a region of space is bounded by the area of its surface. The physics says that entanglement, which is a form of shared information, may literally weave the fabric of space-time. The physics says that information cannot be destroyed, that unitarity is sacred, that the universe keeps perfect records of everything that has ever happened. The physics says all of this about information, and the physics cannot tell you what it is. I want to give you one more number, because this number captures the absurdity of the situation. The Bekenstein bound tells us that the maximum amount of information that can be contained in a region of space is proportional to the area of the boundary, not the volume. For a sphere the size of the observable universe, the bound is approximately 10 to the 122 bits. Every physical process that has ever occurred, every particle interaction, every photon scattered, every gravitational wave rippled, every quantum state collapsed, all of it is encoded somewhere in those bits. And the universe, according to Lloyd's calculation, has used approximately 10 to the 90th of those bits so far. It has performed approximately 10 to the 120th operations. Those are the computational resources of the cosmos. Everything you have ever experienced, every thought you have ever had, every civilization that has ever risen and fallen, every star that has ever burned, it is all part of a computation that has been running for 13.8 billion years on 10 to the 90th bits. You are not the observer. You are not even the computation. You are a subroutine. You are a small, temporary pattern of information processing occurring within a much larger, much older computation that does not know you exist and does not care. And the thing running the computation, the thing that decides which states survive and which are destroyed, the thing that selects pointer states and broadcasts them through the environment, the thing that creates the classical world out of quantum possibilities, that thing is information. And information has no face, no consciousness, no definition. You used to think your mind mattered. Physics proved it does not. You used to think there was something special about awareness, about the subjective experience of looking at something. There is not. The environment looks at everything, constantly, thoroughly, with a precision that makes your visual cortex look like a child's toy. But the thing the environment is doing when it looks, the thing it is exchanging when it interacts with quantum systems, the thing it is collecting and storing and broadcasting, that thing, information, remains the deepest, undefined concept in all of physics. Zurek died in the Black Forest. He was right about everything. He was right that the environment does the observing. He was right that consciousness is irrelevant. He was right that decoherence alone does not solve the measurement problem. He was right that many worlds is the natural interpretation. He was right for almost 50 years. But being right in physics, as in everything else, is not enough. Being right at the wrong time, in the wrong institution, without the right patron, can cost you everything. Wheeler wrote, "Surely someday we will grasp the central idea of it all as so simple, so beautiful, so compelling that we will all say to each other, how could it have been otherwise?" In 1970, the community took 30 years to catch up, and when it caught up, it gave the credit to someone else. The central idea is this: the universe does not need you to look at it. The universe is looking at itself. Every interaction is an observation. Every scattered photon is a measurement. Every entanglement is a recording. The universe is a self-observing system, and the classical world you experience is the residue of that self-observation, the ash left behind after the quantum fire of decoherence has burned through every superposition you might have seen. And the fire burns with information. And information is the one thing that physics cannot live without and cannot define. That is the replacement. That is what sits in the chair where consciousness used to be. An undefined concept, doing undefined work, producing definite results that match experiment to extraordinary precision. The equations work, the predictions are confirmed, the mechanism is real. And the mechanism runs on something that has no physical definition. The universe is not waiting for you to look. It has been looking the whole time. It looked before you existed. It will look after you are gone. And the act of looking, stripped of every human quality, stripped of consciousness and awareness and intention, the raw physical act of one system interacting with another and exchanging information about quantum states, that act is what creates reality. Not for you, not because of you, not through you. The environment does not ask permission. The environment does not wait for awareness. The environment does not care about minds or eyes or brains or the subjective experience of observation. The environment observes because that is what physical interaction is. And the word we use for what it exchanges during that interaction, the word we put at the center of our deepest theories, the word we carved into the foundation of 21st century physics, that word is information, and it is a blank, a placeholder, a name for something we have not yet found. Ze found the mechanism. Zurek named it. Haroche photographed it. 100,000 volunteers tested it. And at the bottom of all of it, underneath the equations and the experiments and the Nobel Prizes and the careers built and the careers destroyed, there is a question that none of them answered. What is information? The universe knows. The universe has been using it since the beginning. The universe built atoms with it, stars with it, galaxies with it, you with it. The universe wove space-time out of it and filled that space-time with matter that computes with it and observers who are made of it. And we, the observers, the subroutines, the temporary patterns, we gave it a name. We said it is fundamental. We wrote it into our laws. We built our deepest theories on it, and we still do not know what it is. Zer knew what it was not. It was not consciousness. He proved that. The proof cost him everything. And the thing it is, the thing that replaced consciousness at the foundation of physics, remains nameless. Not because we have not tried, because the question may not have an answer in any language that human beings or any information processing system embedded within the computation could understand. The dogs are not sleeping. They were never sleeping. They were watching, and they were watching with something that has no name. And they are watching now, right now. As you listen to this, the photons reflecting off your screen are carrying information about your quantum state into the environment. The air molecules around you are scattering off your skin and carrying which state information into the room. The thermal radiation from your body is broadcasting your state to the cosmos. You are being observed. You have always been observed. You were observed before you were born. The atoms that would become you were monitored by the environment for billions of years before they assembled into the pattern that calls itself you. And the pattern that calls itself you is itself a piece of information, a very complex piece, a piece that processes other information and produces outputs and has the strange recursive property of being aware that it is a piece of information. But your awareness changes nothing. The environment was observing before you were aware. It will observe after you stop. The decoherence of your quantum states does not require your participation. It does not require your consent. It does not require your existence. You are not the observer. You are what is being observed. And the thing doing the observing has no mind, no consciousness, no definition, and no name. It is just the universe exchanging information with itself, selecting what gets to be real, and watching, always watching. Let me be more specific about what the Hackermuller experiment actually looked like, because the physical details matter. The Talbot-Lau interferometer that Arndt's group in Vienna used is not like the double-slit experiments you see in textbook diagrams. It consists of 3 gratings spaced at precise intervals. The first grating prepares the spatial coherence of the molecular beam. The second grating acts as the diffracting element. The third grating, combined with a detector, reads out the interference pattern. The gratings themselves are silicon nitride membranes with slit widths of approximately 90 nanometers, fabricated using electron beam lithography. The C70 molecules were sublimated from a powder source heated to roughly 600 degrees Celsius. They formed a molecular beam that traveled through the 3 gratings over a total path length of about 1 meter. At the detector, they counted individual molecules arriving at different positions, and after accumulating thousands of counts, the interference pattern emerged. A sinusoidal variation in the detection probability as a function of position behind the 3rd grating. A wave pattern. Made by objects composed of 70 carbon atoms, each one with a mass of 840 atomic mass units, roughly 1,000,000 times heavier than an electron. That alone is extraordinary. These are not photons, these are not electrons, these are molecules. Objects with internal structure, with rotational and vibrational modes, with the ability to emit and absorb infrared radiation. And they behave as waves. They produce interference fringes. They are quantum objects, despite being, by any intuitive standard, things. But the purpose of the Hacker-Miller experiment was not just to show interference, it was to show its destruction. By heating the molecules with an additional laser after they left the source but before they reached the first grating, the experimenters raised the internal temperature of the C70 molecules. At about 900 Kelvin, the molecules began emitting thermal photons, infrared photons, with wavelengths comparable to the slit spacing. Each thermal photon that escapes from a C70 molecule carries Wigner path information. If the photon's wavelength is short enough relative to the slit separation, the photon could in principle tell you which slit the molecule went through. And once that information exists in the environment, even if nobody collects it, even if the photon flies off and is absorbed by the laboratory wall and is never measured by anyone, the interference is destroyed. What the experimenters observed was a smooth, continuous degradation of the interference visibility as the temperature increased. At 900 Kel, full visibility. At 1500 Kelvin, partial visibility. At 3000 Kelvin, zero visibility. Classical behavior, the fringe pattern, was gone. The molecules still arrived at the detector, but they arrived as particles, not waves. The quantum behavior had been destroyed by information leaking into the environment in the form of thermal photons. And the quantitative agreement with theory was precise. The predicted visibility as a function of temperature, calculated from the Juice-Z decoherence model with the known emission properties of heated C70, matched the experimental data within error bars. The theory that Zurek had proposed in 1970 and that Juice and Zurek had quantified in 1985 was confirmed by direct measurement in 2004. You could heat a molecule and watch quantum mechanics die. You could turn a knob and control the rate at which the environment murdered the superposition. The knob was temperature. The mechanism was photon emission. The physics was decoherence. And the variable that controlled everything was information. How much which path information was leaking into the environment. That is all. That is the entire story of why the classical world exists. Information leaks, superpositions die, and there is a further detail, but I think captures the strangeness of this. The Arndt group later showed, in subsequent experiments with even larger molecules, that you can partially restore quantum interference by selecting molecules that did not emit photons. If you filter your data to include only those molecules that stayed cold, that did not radiate, that kept their Wigner path information to themselves, the interference fringes reappear. The quantum behavior was not destroyed in the molecules. It was destroyed in the information. Control the information and you control reality. That sentence should make you uncomfortable because it sounds like it is saying that information is more fundamental than matter, that the behavior of a physical object whether it acts as a wave or a particle, is determined not by the object itself, but by the information available about it. And that is exactly what it is saying. That is what decoherence says. That is what every experiment since Haroche in '96 has confirmed. The object does not decide whether it is a wave or a particle. The information decides, and the information is not inside the object. It is in the environment. It is in the scattered photons and the disturbed air molecules and the thermal radiation and the gravitational field fluctuations. It is everywhere except in the object itself. You are not a wave or a particle. You are whatever the environment's information says you are. And the environment has a lot of information about you. It has been collecting it since the atoms that compose you were first forged in the cores of dying stars. Every photon that has ever bounced off a surface that those atoms were part of, every thermal fluctuation, every gravitational interaction, all of it has been recorded, distributed, and broadcast by the environment. The universe has a file on you. It has had one since before you were born. And the file is not in a cabinet or a computer or a database. The file is the environment itself. It is the correlations between the particles that make up your body and the particles that make up everything else. It is the entanglement, the shared information, the web of quantum correlations that connects you to every photon that has ever touched you. And that file, that web of correlations, that network of information is what makes you classical. It is what makes you definite. It is what prevents you from existing in a superposition of being here and being somewhere else. The environment knows where you are. The environment has known for a very long time. And because the environment knows, you are not in superposition. You are in one state, one position, one configuration, the one that the environment's information selects. Not because the environment chose you, not because the environment wanted you to be here, but because information flow, which is just physics, just interactions between quantum systems, is what creates definiteness. And you are the beneficiary or the victim of that process. The Copenhagen interpretation said, "Shut up and calculate." Decoherence says, the universe already calculated. It calculated faster than you can think. It calculated with every interaction between every pair of particles in your light cone. And the result of that calculation is the classical world. But the calculation runs on information. And information is the blank at the center of the equation. Serge saw the calculation in 1970. He was 50 years ahead of the Proietti experiment. He was 26 years ahead of Haroche. He was 12 years ahead of Zurek's formalization. He was alone in Heidelberg with an insight that would take the rest of physics a generation to accept. And the insight is this: you are not special. Your consciousness is not special. Your mind plays no special role in the machinery of the universe. You are a subsystem entangled with an environment, and the environment's information about you is what determines your classical properties, not your awareness, not your attention, not your subjective experience of observation. The environment does not need you to observe. It observes by existing. Every interaction is an observation. Every photon is a measurement. Every entanglement is a record. The universe is a self-measuring system, and the classical world is the outcome of that self-measurement. And the thing that is measured, and the thing that does the measuring, and the thing that is exchanged between them, and the thing that is created by the exchange, and the thing that is conserved through every process, And the thing that is more fundamental than matter and energy and space-time itself is information. And information is a word that means everything and defines nothing. That is the replacement. That is what sits where consciousness used to sit. It works better. It predicts correctly. It has been confirmed by every experiment ever designed to test it. And it is, at its core, a mystery wearing the clothes of an explanation. I want to tell you about Wheeler's journey because it mirrors the journey of physics itself, and because it ends in a place that nobody expected. John Archibald Wheeler was born on July 9th, 1911, in Jacksonville, Florida. He earned his PhD at Johns Hopkins at the age of 21. By 24, he was working with Niels Bohr in Copenhagen on nuclear fission. He co-authored the Bohr-Wheeler theory of nuclear fission in 1939, the paper that provided the theoretical basis for both nuclear reactors and nuclear weapons. He worked on the Manhattan Project. He coined the terms black hole and wormhole and quantum foam and it from bit. He supervised more successful PhD students than almost any physicist of the 20th century. Richard Feynman was his student. Hugh Everett was his student. Wojciech Zurek was his student. Kip Thorne was his student. Wheeler's personal life was marked by a tragedy that shaped his physics in ways that are rarely discussed. His younger brother, Joe Wheeler, was killed in combat in Italy on October 25, 1944, during World War II. John Wheeler had been working on the Manhattan Project. He later said that if the bomb had been ready sooner, it might have ended the European war earlier, and his brother might have survived. This haunted him for the rest of his life. Decades later, when Wheeler proposed his delayed choice experiment in 1978 and 83, the experiment that showed a measurement made now can determine what a photon did in the past. Colleagues noticed a connection that Wheeler himself acknowledged only obliquely. A man haunted by the question of whether the past could have been different proposed an experiment showing that the past is not fixed. The personal and the physical were not separate threads. They were the same thread running in both directions. Wheeler's delayed choice experiment, later realized in the laboratory by Alain Aspect in 2007 and by Alberto Peruzzo in 2012, demonstrated that a photon's behavior as a wave or particle is determined not at the moment it enters the apparatus, but at the moment of detection. You can choose, after the photon has already passed through the double slit, whether to detect which path it took or to observe its interference pattern. And the photon's past behavior conforms to your present choice. Not because your consciousness reached back in time, because the information structure of the experiment was not determined until detection occurred. Again, information, not consciousness, not mind, information. Wheeler took this further than anyone expected. His participatory universe idea was not a casual speculation. It was a sustained philosophical program that occupied the last 30 years of his life. He argued that the universe cannot meaningfully be said to exist until it is observed, not observed by consciousness, observed by the registration of information. Every yes or no measurement, every binary bit of information recorded anywhere in the universe participates in bringing the universe into existence. He drew a picture that became famous, a large capital U representing the universe with an eye at one end looking back at the beginning. The universe brings forth observers, and observers bring forth the universe, not in a mystical sense, in an information theoretic sense. The universe exists because information has been registered, and information requires something to register it. And the thing that registers information is itself part of the universe. This is the Ouroboros at the heart of the information interpretation. The universe creates observers through physics. Observers create information through measurement. Information creates the classical universe through decoherence. The classical universe creates more observers. The loop has no beginning and no end, and nobody can tell you what the loop is made of. Wheeler told John Horgan of Scientific American in an interview, "We are not only observers, we are participators. In some strange sense, this is a participatory universe." And when Horgan pushed him on what participatory meant, Wheeler admitted he did not know. He said he had an idea of an idea, an inkling, a direction, not a theory. He died on April 13th, 2008, at the age of 96. He never completed the program. He left behind "it from bit" as a slogan, a direction, a challenge, and the challenge remains unanswered. I want to make one more number visceral before we reach the end, because I think the scale of decoherence is the single most undertold story in physics. You are sitting somewhere right now. You are a macroscopic object at roughly 300 Kelvin. Every second, approximately 10 to the 21st, thermal photons leave your body in the form of infrared radiation. Each one carries information about your quantum state into the environment. That is 1,000 billion photons per second, each one an act of environmental observation. But thermal photons are not the only thing. Air molecules are colliding with your skin at a rate of approximately 10 to the 27 collisions per second. Each collision is an interaction. Each interaction transfers information. Each information transfer contributes to decoherence. Add to that the cosmic microwave background, the remnant radiation from the Big Bang, which bathes everything in the universe in a sea of photons at 2.7 Kelvin. Add gravitational interactions with every mass in your vicinity. Add the neutrinos passing through your body, roughly 65 billion per square centimeter per second. From the sun alone, you are not being occasionally observed by the environment. You are being observed continuously by everything at rates that exceed any number you have ever thought about for any reason. The environment does not sample your quantum state. The environment saturates it. The environment drowns it. The idea that your consciousness could play any role in this process is like suggesting that your voice could influence the outcome of a thunderstorm. And this is what Serge saw in 1970. Working on nuclear physics in Heidelberg, he saw that the environment is an observation machine of such incomprehensible thoroughness that the question, does consciousness collapse the wave function, is not even wrong. It is irrelevant. It is asking about a candle in the presence of a supernova. There is one more thread I want to pull before the end, because it connects everything. In 2013, Juan Maldacena and Leonard Susskind proposed what is now called the ER equals EPR conjecture. ER refers to Einstein-Rosen bridges, also known as wormholes, geometric tunnels through space-time. EPR refers to Einstein-Podolsky-Rosen entanglement, the quantum correlations between distant particles. Maldacena and Susskind proposed that these are the same thing, that every pair of entangled particles is connected by a wormhole. The that quantum entanglement literally creates the geometric structure of space-time. If this is correct, and a growing body of theoretical evidence suggests it is, then the implications for our story are staggering. Decoherence works by creating entanglement between a system and its environment. Every act of environmental observation creates entanglement. And if entanglement creates space-time geometry, then decoherence is not just destroying quantum superpositions, it is building the spatial structure of the classical world. The environment does not just select what is real. The environment constructs the space in which the real things exist. Information does not just determine which outcome you see. Information determines the geometry of the space-time in which you see it. The fabric of reality is not a pre-existing stage on which decoherence plays out. The fabric of reality is woven by decoherence, thread by thread, entanglement by entanglement, bit by bit. If ER equals EPR is correct, then Wheeler's it from bit is not a metaphor. It is a construction manual. The universe is literally built from information. Space-time is made of entanglement. The classical world is made of decoherence. And decoherence is made of information exchange. Every level of the hierarchy runs on the same undefined concept. Zer's insight that the environment is the observer was the first step. Zurek's formalization that Einselection creates the classical world was the second. Wheeler's vision that information is fundamental was the third. And the ER equals EPR program, that entanglement builds space-time, may be the fourth, but every step runs on information, and every step fails to define it. That is where physics stands in 22.6. The framework is more successful than ever. The experiments are more precise than ever. The theoretical landscape is more unified than ever, and the central concept, the concept without which none of it works, remains a blank. We know what information does. We do not know what information is. We know that consciousness does not collapse the wave function. We do not know what does. We know that the environment observes everything with staggering thoroughness. We do not know what observation means. At the deepest level, we know that Zer was right. We know that Zurek was right. We know that Wheeler was pointing in the right direction. We know that the consciousness interpretation was wrong, tested and falsified. And we know that the replacement, the thing that took consciousness's place at the foundation of physics, is a word without a definition, doing work that nobody fully understands. I want to walk you through what it actually looks like when a laboratory recreates Wigner's Friend scenario, because the Proietti experiment deserves a full treatment. The experiment was published in 2019 in Science Advances by Massimiliano Proietti and colleagues at Heriot-Watt University in Edinburgh. The theoretical framework came from Czeslaw Bruckner, who in 2017 proposed an extended Wigner's Friend scenario that could be tested with entangled photons. Here is the setup. You have two laboratories. Call them Alice's lab and Bob's lab. Inside each lab, a friend makes a measurement on a photon. The friends are not human beings. They are optical circuits that record a measurement outcome. But that is precisely the point. The experiment tests whether any observer, human or not, can be assumed to have a definite, observer-independent outcome. Alice and Bob, outside the labs, have a choice. They can either open their friend's lab and read the recorded outcome, or they can perform a different measurement on the entire lab, treating the lab and the friend and the photon as one composite quantum system. If observer-independent facts exist, if each friend always has a single definite outcome, regardless of what Alice and Bob do, then the statistics of Alice's and Bob's results must satisfy a certain inequality. It is similar to a Bell inequality, but tailored to the Wigner Friend scenario. The experiment violated this inequality by 5 standard deviations. 5 sigma. That is the threshold particle physicists use to claim a discovery. It is the threshold used to confirm the Higgs boson. And what the violation means is this: you cannot simultaneously maintain 3 things: that quantum mechanics is correct, that measurements have single definite outcomes, and that those outcomes are independent of other measurements performed elsewhere. At least one of these assumptions must be wrong. If quantum mechanics is correct, and every experiment so far says it is, then either measurements do not have single definite outcomes, which is the many worlds view, or outcomes are not independent of distant measurements, which implies a radical form of observer dependence. Either way, the objective, observer-independent classical reality that you experience every day is not fundamental. It is emergent. It is approximate. It is a consequence of decoherence and information flow, not a bedrock feature of the universe. And this is what I mean when I say the replacement is worse. The consciousness interpretation, for all its problems, have at least preserved the idea of a single, definite, real world. Your mind collapsed the wave function and produced one reality. It was wrong about the mechanism, but it preserved the conclusion: there is one world, it is real, it is definite. The information interpretation opens the door to something far more unsettling. If the classical world depends on information access, and different observers have different information access, then different observers may literally inhabit different classical realities, not metaphorically, not as a matter of perspective. Physically, the decoherence that creates your classical world is specific to your information. Another observer with access to different environmental correlations might see a different classical world. This is not speculation. This is what the mathematics says. And the Proietti experiment is the first direct evidence that the mathematics is right. Now I want to go deeper into the black hole information paradox, because it is the arena where information's fundamental status was forged, tested, and ultimately confirmed. And the story is more dramatic than most people realize. In 1974, Stephen Hawking published a paper that terrified theoretical physics. Working at the intersection of quantum mechanics and general relativity, he showed that black holes are not truly black. They emit radiation. The radiation has a thermal spectrum, meaning it is completely random, completely featureless, completely devoid of information about what fell into the black hole. It is the most boring radiation in the universe, a perfect thermal bath. This means that as the black hole evaporates, as it slowly radiates away its mass, the information about everything that ever fell in is gradually lost. A star falls in, a book falls in. All the quantum information about the state of the star, the words in the book, the memories of the person, all of it is encoded in the black hole. And as the black hole evaporates, none of that information comes back out. The radiation carries no record. The information is destroyed. But quantum mechanics says information cannot be destroyed. Unitarity, the principle that quantum evolution is reversible, that the present uniquely determines both the future and the past, is one of the most fundamental principles in physics. If you know the quantum state of the universe at any one moment, you can in principle reconstruct the state at any other moment. Past and future are both contained in the present. Information is conserved. Hawking's calculation said, no. Black holes violate unitarity. Information dies. This launched a war. On one side, Hawking and his allies, who were willing to modify quantum mechanics to accommodate black holes. On the other side, Leonard Susskind and Gerard Hooft, who insisted that information must survive, that unitarity is sacred, that whatever happens inside a black hole, the information must eventually come back out in the radiation, even if we cannot yet see how. Susskind later wrote a book about it called The Black Hole War, published in 2008. He described the conflict as the most important intellectual battle in physics since the Bohr-Einstein debates, and he was not exaggerating. The resolution came from an unexpected direction. The ADS/CFT correspondence, discovered by Juan Maldacena in 1997, showed that certain gravitational theories are mathematically equivalent to certain quantum field theories living on the boundary of space-time. The boundary theory is manifestly unitary. It conserves information by construction. And if the boundary theory is equivalent to the gravitational theory, then the gravitational theory must also conserve information. Black holes cannot destroy information because the equivalent description on the boundary does not allow it. Hawking conceded in 2004 in Dublin. But the deeper lesson went beyond black holes. The lesson was that information conservation is so fundamental that the geometry of space-time itself bends to accommodate it. Space-time is not the fundamental layer. Information is. Space-time emerges from information, not the other way around. The 2019 derivation of the Page curve using the island formula made this even more concrete. By accounting for quantum entanglement between the radiation and the black hole interior through so-called quantum extremal surfaces, physicists showed that the information does come out, slowly, encoded in subtle correlations among the radiation particles. The information is not destroyed. It is scrambled so thoroughly that recovering it would require collecting every single Hawking radiation photon and performing measurements of extraordinary precision. But it is there. It is always there, because information cannot die. And that is why the physics community now treats information conservation with the same reverence it gives energy conservation. Information is not optional. Information is a law. Break it, and the rest of physics breaks with it. So when I tell you that decoherence works by information leaking into the environment, that is not a casual description. That is an invocation of one of the deepest principles in physics. The environment collects information about quantum systems. That information is then distributed redundantly across environmental degrees of freedom. It can be accessed by multiple observers. It can never be destroyed. It creates objectivity through redundancy. It creates classicality through decoherence. It creates space-time through entanglement. Information does everything, and information has no definition. I want to give this the weight it deserves. I have been reading about this subject for an unreasonable amount of time, and I still do not know how to sit with this contradiction. The most successful and rigorously tested framework in modern physics runs on a concept that nobody can ground in physical terms. It is as if chemistry worked perfectly, but nobody could tell you what an atom is. As if biology worked perfectly, but nobody could tell you what a cell is. The equations produce correct answers. The experiments match the predictions. the framework is astonishingly successful, and at the center of it all is a hole. I personally think this is the most underrated open problem in physics. It does not have the glamour of quantum gravity or the publicity of dark energy, but it is deeper than both. Because quantum gravity and dark energy assume that we know what we mean by information. If we do not, then the foundations of both programs are built on undefined ground. And now, the final biographical thread. Zurek, at Los Alamos, continued extending the Decoherence program. His quantum Darwinism paper in 2009 was the capstone. The idea is this: standard decoherence explains why you do not see superpositions, but it does not explain why multiple observers agree on what they see. If the classical world is a consequence of your particular information access, why do you and I agree that the chair is in the corner? Why is reality shared? Zurek's answer is redundancy. The environment does not just absorb coherence, it makes copies, many copies. When a photon bounces off the chair, it carries a copy of the chair's position into the environment. When the next photon bounces, it carries another copy. Every scattered photon is a copy. Every reflected light ray is a copy. The environment creates millions, billions, trillions of redundant copies of the pointer state information, and different observers accessing different fragments of the environment all get the same information, not because there is one objective reality, because the environment has broadcast the same message to everyone. This is quantum Darwinism. The name comes from the analogy with biological natural selection. Just as biological evolution selects for fitness through reproductive success, the environment selects for certain quantum states through informational redundancy. The states that survive are the ones that leave the most copies. The pointer states, the classical states, are the fittest states. They survive because the environment copies them most efficiently. And objectivity in this framework is not a metaphysical given. It is a physical consequence. It is a consequence of redundant information. We agree on what is real because the environment has copied the answer so many times that every observer finds the same message no matter where they look. That is beautiful. It is also deeply strange because it means that objectivity is not about the world. It is about the information structure of the environment. It means that if the environment did not create redundant copies, if the information about quantum states were distributed uniquely rather than redundantly, different observers would see different realities, and there would be no fact of the matter about which one is correct. The Proietti experiment suggests this is not just a theoretical possibility. It may already be happening at the quantum level right now. The chair is in the corner because the environment says so, not because it is there in some mind-independent, information-independent sense. The environment made 1 billion copies of that fact and distributed them to everyone. And we call that objectivity. But it is not the bedrock kind of objectivity that most people imagine. It is the kind that depends on a specific physical process. Redundant information copying, occurring in a specific physical medium, the environment, through a specific physical mechanism, decoherence. Take away the environment, and the chair is in every possible position simultaneously. The environment is what pins reality down, and the tool it uses is information. And that tool has no definition. Zay spent his career alone with this insight. He saw it before anyone else. He saw that the environment is the observer, that decoherence is the mechanism, that the classical world is not fundamental, but emergent, and he saw, more clearly than anyone except perhaps Bell, that this does not solve the problem. It displaces it. It moves the mystery from consciousness to information, from mind to mechanism, from philosophy to physics. But the mystery remains. In his final years, Zurek continued publishing on decoherence and its implications for the direction of time, for the arrow of entropy, for the emergence of the classical world from the universal wave function. He was a quiet, precise, uncompromising thinker. He did not seek fame. He did not court the media. He did not make YouTube videos or write popular books or give TED Talks. He wrote papers. He maintained his website. He answered emails from people who had read his work. And on April 15th, 2018, in the Black Forest, the man who removed consciousness from quantum mechanics died. The environment absorbed the information. The photons scattered. The thermal radiation carried his quantum state into the cosmos. And the decoherence, the very process he discovered, ensured that his state, like every other macroscopic state in the universe, was selected, broadcast, and recorded by the environment with absolute thoroughness. He became part of the computation, as we all will, as we all already are. The universe is not watching you with eyes or consciousness or intention. The universe is watching you with physics, with photons and phonons and gravitational waves and thermal radiation, with the relentless automatic indifferent process of information exchange between quantum systems. The process he discovered, the process he named before anyone would listen, the process that runs on something nobody can define. There is a question that has been forming in the back of your mind, and I want to address it directly. If decoherence does not solve the measurement problem, and if information is undefined, then what exactly have we accomplished by removing consciousness? Are we just rearranging words? Is this progress, or is it just a more sophisticated form of confusion? I think the answer is that it is both. And I think the honesty of that answer is more valuable than false clarity in either direction. Here is what decoherence accomplished. It explained quantitatively, verifiably, with predictions confirmed to extraordinary precision, why the classical world exists, why you never see superpositions, why measurement results look definite, why cats are alive or dead, never both. It explained the mechanism by which quantum mechanics gives rise to classical physics. And it did this without invoking anything outside physics. No consciousness, no special observers, no collapse postulate added by hand, just the Schrödinger equation, applied consistently to the system and its environment. That is genuine progress. That is the kind of progress that wins Nobel Prizes, or should. Here is what decoherence did not accomplish. It did not explain why you see one outcome rather than another. It did not bridge the gap between and or. It did not tell you why the cat is alive rather than dead. It did not solve the measurement problem. And the framework it uses, the language of information transfer and environmental monitoring, rests on a concept that has no agreed-upon physical definition. To be clear, this is not a failure specific to decoherence. It is a feature of the current state of physics. The measurement problem is open. Every interpretation of quantum mechanics is an attempt to close it. None has succeeded in a way that commands universal agreement. Decoherence is the mechanism. The interpretation is still missing. And the mechanism runs on undefined fuel. I think there is something valuable in sitting with this discomfort rather than resolving it prematurely. The consciousness interpretation resolved the discomfort by saying, "Your mind does it." That was comforting and wrong. The Copenhagen interpretation resolved the discomfort by saying, "Do not ask the question." That was professionally convenient and intellectually dishonest. The many worlds interpretation resolves the discomfort by saying, "All outcomes occur." That may be right, but it is not testable. And the information theoretic approach resolves the discomfort by saying, "Information is fundamental." That may also be right, but it replaces one undefined concept with another. The honest position is, we do not know. We know more than we did in 1932. We know that consciousness is irrelevant. We know that the environment is the observer. We know that decoherence is real and precisely quantifiable. We know that information plays a role more fundamental than anyone expected. And we do not know what information is, or why one outcome occurs, or what the world is made of at the deepest level. That is not a failure. That is the frontier. And the frontier is always uncomfortable. But I want to point out one more thing about the sociology of this story, because it connects to something larger. The reason you were taught the consciousness version is not that physicists lied to you. It is that the accurate version is harder to sell. It is harder to fit into a 10-minute YouTube video. It is harder to connect to self-help. It is harder to put on a book cover. The accurate version says, "You do not matter. The environment does the work. The mechanism runs on something undefined. And the deepest problem in physics is still open." That is a hard sell. The inaccurate version says, "Your mind shapes reality." That is an easy sell. And this dynamic, the preference for comfortable oversimplification over uncomfortable accuracy, is not unique to quantum mechanics. It is the fundamental failure mode of science communication. It happens in every field, on every topic. Every time the real answer is less flattering, or less clear, or less marketable than the simplified version, the simplified version spreads. The real version sits in journals. And the cost is not just ignorance. The cost is that when someone finally does encounter the real version, they feel betrayed. They feel like the educational system failed them. They feel like they were lied to. And they were, not by conspiracy, not by malice, but by a system that rewards accessibility over accuracy, and that consistently chooses the version that makes the audience feel good over the version that is true. This story, the story of consciousness being removed from quantum mechanics, is a case study in that failure. You were taught wrong, not by fringe sources, by mainstream documentaries, mainstream books, mainstream science communication. The people who taught you were themselves taught wrong. It is a chain of misunderstanding stretching back decades, reinforced by economic incentives, sustained by the flattering appeal of cosmic self-importance. And the fix is not simple. You cannot just replace consciousness with information in the popular narrative and call it a day. Because information, as a concept, is harder to understand than consciousness. Consciousness is something you experience. Information is something you use. The replacement is more abstract, more technical, more resistant to popularization. But the replacement is also true, and truth, even when it is uncomfortable and undefined and resistant to simplification, is the thing that physics owes you. Serge understood this. He spent his career telling the truth about decoherence, even when the truth was professionally dangerous, even when the truth was not what people wanted to hear, even when the truth led to implications that even he found difficult. He wrote, in one of his later essays, The quantum universe is very large. The quantum universe is very strange. And the quantum universe does not care about our philosophical preferences. The universe does not care. The environment does not care. The information does not care. The decoherence does not care. None of it cares. But it all works. It all works with terrifying precision. The timescales match. The experiments confirm. The mathematics converges. The framework that Zurek proposed in 1970 and that Zurek formalized in 1982 and that Haroche photographed in 1996 and that 100,000 volunteers tested in 2016, that framework is confirmed. And at the center of that framework is a word that nobody can define, a concept that does everything and explains nothing, a placeholder that physics has elevated to the status of a fundamental principle. Information, the thing that was supposed to make quantum mechanics make sense, the thing that was supposed to replace the mysticism of consciousness with the rigor of physics. And it did. It replaced the mysticism. It brought the rigor. The experiments work. The predictions hold. The mechanism is real. And the mechanism has a hole at its center. And the hole is shaped exactly like the one it was supposed to fill. The dogs were never sleeping. They were computing. They have been computing since the Big Bang on 10 to the 90th bits, performing 10 to the 120th operations, weaving space-time from entanglement, building the classical world from decoherence, selecting outcomes from superpositions, broadcasting reality through redundant information. And the computation continues, right now, through you, around you, with every photon that touches your skin, every air molecule that brushes your face, every graviton that tugs at every atom in your body. You are inside the computation. You are part of the computation. You are made of the computation. And the computation runs on information. And information is a word. And the word has no definition. And the universe does not wait for definitions. It computes.